back. Let me see. I'm seeing if there's the delay or anything. Come on, come back, come back, come back, come back, come back. And I think we're back live. Camera's still working, so that's good. Sorry, everybody. I hope you're back with me. So yeah, my camera froze for whatever reason. I'm not sure what the deal is. It is quite annoying. I don't think it's too hot up here in the room, but I did just reboot the PC. So I hope you guys are back here with me now. Let me see who all is still in chat. Looks like I got a few of you still there in chat. Built Over Bot, Chewy, Mr. Wizix, Red Sumo, Rob, Thunder Keys, Timor. Thanks for hanging around. Sorry for having to blip the stream. I don't know why, but this camera had frozen on me. So we're back, and we're going to try and keep going on this Veterans Day. So yeah, Mrs. Dragon is fine. She's just sore. I mean, falling on concrete sucks at any point in time, but she is okay. Just like I said, a little bit sore, and we'll just say her pride's a little wounded. But yeah, so I got this really, really long cable that they give us. This cable is a standard, kind of like the, well, here, let me go to this side. A standard style, we'll say, CAN bus type. It's the XT30 2x2. So the XT30 with the two almost look like, I was gonna say JST, but I think they're actually like DuPonts or maybe some microfit. And then the other side, we're at a 2x3 microfit. This connects into the board that's up underneath. So what we're going to do is we're going to start off by connecting this here. We'll start looping it around in the cable chain, and then that is going to be the, we'll just start working our way back around and getting everything in the cable chain. And which side is which? Okay, so that's the bottom. This will be the one up at the tool head. And what I'm actually going to do is lay this in the chain first, right? Making sure I'm getting it in the right order. So the tool head is the Audi, the end over here on the X is the innie. And by the innie, I'm talking about the end piece is, does it go on the inside or the outside of the cable chain? In this case, the end at the tool head is the Audi, which means this needs to be the one that goes on the inside of that outer piece. So now this cable is cable chain rated. Normally you would not want to put these cables in here, but this is a cable chain rated cable. So I'm just closing all of the pieces here so that I can get this ready to clip in. And we'll clip in this side, making sure that we're not pinching the wire at all. Okay. And then we'll make sure once again that we're getting this done up inside and not pinching the wire or any of the wires in this area. Okay. And then this piece right here is going to plug in with the XT30 at the bottom. Hey, Chris. Yep, we are back. And we may need to pull this cable through a little bit. Just play with it to get our right length. And we do have that little strain relief spot on here. So we'll pull this forward a little bit and we'll add a zip tie there for strain relief. So if you don't know, these little tabs at the end of the little tabs at the end of your end post here, those are for strain relief so that you can wrap a zip tie around it and zip tie your cable to it, therefore keeping that end from moving as much. You don't want, especially like this end here, moving because it's going to put strain on your actual connector there. So normally you'd want to do two. With the way this comes around, I think one's going to be okay there. And at this far end over here, we're also going to zip tie it down. And that way the cable can like bend around the chain, but it's not going to move within the chain, so to speak, like through the chain, I guess. So we're going to zip tie this down on this end. You didn't refresh? Well, shame on you, Chewy. But yeah, I think, you know, if y'all missed the intro, welcome on in for a Veterans Day stream. So this is a federal holiday in the United States, and as a veteran, I very much appreciate having this day off. It's always nice to have the day off and be able to relax and hang out with friends, and some of those friends being other veterans. So one of the things that we're going to need to do is, and this is where we get a little bit squirrely, we're going to need to get this cable back in the cable chain, and then we'll need to get our thick cable in the cable chain. I'm just trying to figure out once again which way it goes. And I think I want my PTFE cabling, the 4 wires, at the bottom. So we'll lay that in there. And then when I say this is where it gets tricky, it's because I'm running my cables in 2 different directions. And they're going to be laying over the top of each other. So we've got our 4 PTFE wires that make up our end stop. That's going to be in there. And then we're going to have our other cable. And this needs to be laying basically in the other direction. And this is why it's going to be more of a pain in the ass. Ugh. This is at this end. Because I didn't pull this wire all the way out, I'm trying to like keep it in here and laid in here. And then this cable is going to lay in here over the top. And we're going to be playing with the length of this cable as we try and get it laid in place here. And what I'm going to do is do the one end, being the end that comes down, because the way the cable goes, it's going to go in there in this orientation. So we're going to need to make sure that we can at least get some of these closed up on it, where we're not catching a cable. but we're also going to need to be able to move these cables around some in the cable chain. And I'm just going to go ahead and close it all up. What the hell? No cameo from Diesel. Not today, but I will say if a call comes in, the stream ends immediately. So this is kind of a rough day for some vets. Diesel being one of those. Some vets had uneventful careers. Some vets decidedly did not have uneventful careers. And the best thing we can do is be here for each other on Veterans Day. And like I said, if a call comes in, I'm out without a second thought. So just be aware of that. So what I'm going to do is I'm going to bring this in here down through this slot in the cable chain. And then this is going to come down and plug in. So I'm going to make sure this gets plugged in. This will get zip tied around through this slot. There are a couple of places for zip ties to go in here. So let me get the zip tie started. There we go. And there is a spot for this cable to go right up the inside here. I'm not sure if you guys can see that on the camera, but we're going to bring that cable right up in this groove in the printed part, right around the edge of our extrusion. And we'll just try and work our wires in there. They should be able to work in and around there so that they're in there protected. Might have to do it one at a time, kind of like we do on the LEDs on the stealth burner in order to get them hooked behind there. So that's there. We will go ahead and get the one zip tie in. Now, this cable can also, well, is also going to need to go in there. So actually I need to pop the zip tie back off because I didn't get the big cable in there. I knew I was going to be forgetting something. Once again, we're going to try and get this cable down into that little grooved slot. Bring the thick cable up, down, and around like so. Basically what we're doing is at every point possible, we're going to be locking this cable in place so that it can't move in the chain. Rotating around the chain, we're good, but we don't want it moving in the chain this way because that's where it's going to get the most, whatchamacallit, I guess like rubbage, friction, adherence. I'm going to loop both of these kind of around the edge there. Or up. I don't know. We'll see. There are two zip ties in this vertical rise here, and we do want to get both of those in. So work on getting this in and around these. Yeah, you're one of the lucky ones. Me too. I mean, I saw some stuff, but not, um, I'll just say I wasn't like special ops or any of that kind of crazy. It was just, um, I'll say normal military stuff. All right, so we'll get this down in there. And this will give us an idea of how we want to do this cable. Because once again, we want to make sure that we're not causing too much of a bend there on this big thick cable, but also that it's not going to get in the way of anything like our Z-axis. So we're going to make sure that everything goes along the outside edge of this tie down point. We're going to do one zip tie. I'm not going to do multiple ones here. I think one will be good enough for this point, just to kind of hold that cable so it's not rubbing against the panel the whole time. Because once again, things that rub will wear over time, and we don't want to wear a hole in the side of that. But yeah, like I said, I luckily was not in the complete thick of things, but I do know people that were. Diesel being one of them. So what are we up to this morning? Hey, Lee Marie, welcome on in. Thank you, and happy Veterans Day to you. So we've been working, the whole plan was to, this is the 2.4 known as Kyber Dragon. The plan is to get a box turtle on this. And as all good plans, go, it was great until we made first contact with the enemy. The enemy just being, well, reality, right? So what we started doing was we were already cabling stuff up. We were like, oh, this is going to be easy. It just needs CAN bus, blah, blah, blah. And then I realized I had a standard Octopus board in there. No problem. I don't like those RJ11 CAN bus things that are on the Octopus, so I was going to do a UTC. Okay, and this had the standard LTO or LDO board, so it had the 14 pin plus the 2 pin to provide power and stuff like that. And then we got to looking, and I needed to add a sensor in here. So we got the sensor installed, and I was like, oh, I can put it in the X in-stop position on the LDO toolboard. Well, no, you can't, because the XY in-stop is a separate dedicated wire. That's the 4-wire FET cable that's still in here, right? And then it all went back to the LDO breakout board. So the 4-pin XY goes in, and then the XY in-stops come out from that board and go to the Octopus board. So what I was sitting there thinking was, well, if I unplug this and just unplug the end underneath, leave it plugged in here, it's not going to hurt anything. And then we can basically, we'll be doing sensorless homing on X and Y. And then that frees up the X end stop that I can use for the filament runout sensor. Well, the problem with that thought is now I have to try and configure in sensorless homing, which was something I wasn't wanting to do or ready to do or what have you. So then we got to thinking, well, the LDO board is a separate tool head board. It has an XY in stop on it. Boom, I can use both of those for the 2 filament runout sensors in here and still run the standard switches. Well, in doing the Nitehawk board, then that gets rid of a lot of the stuff that's coming through the toolhead board, and we're going with our USB cable instead of the 14-pin wire thing. So we basically started stripping wires. And then we got to looking, okay, how are we going to configure up the Nitehawk board? And we noticed that the Rev D version of the LDO kit not only includes the Nitehawk board, but a Leviathan. Well, I also had a Leviathan sitting here. So this is now a quasi-Rev D, where it has a Leviathan board and a Nitehawk in it, but it's a Rev C kit. So that's kind of where we're at. It's we did a mod, and then we just kept going down the rabbit hole. And now what we're doing is we're just working back through getting all of our wiring back in place so that we can then flip this back over and continue wiring up underneath. And we'll get into doing the firmware and stuff, because we did do an MCU swap, and we have a toolhead board that now requires firmware. So we're going to have to do some adjustments to our firmware and things like that in order to get this going. Okay, now this stuff goes into our last, come here. This stuff will go into our last cable chain. We'll figure out which way this goes so that we can lay our cables in there in the right direction. And of course, as always, it would always be easier to just say, oh, well, let's just take all the wires out and redo the wiring. But why would we do that? I mean, that sounds relatively easy. But, you know, we're going to try not to remove anything that we don't, which just means it gets harder for us. I know you know what I mean by that, Lee Marie. Like, no, I don't need to take off these panels or this part or that part. I can get those wires out. And then you spend like probably twice as long trying to work around parts than you would have if you just pulled everything out and kind of redid it from scratch. And of course, with a flying gantry, every time you try and push things around and push things in, it moves the gantry around. So, but the main purpose here was I have been asked, well, not been asked, but Evocate 3D, which is a local 3D printing company here in Raleigh, North Carolina, had been looking for an LDO kit that they could build and put on display in their showroom. Well, you know me, I'm like, hey, I've got an LDO based kit sitting in my shop that I cannot run simply because, well, let me rephrase that. I can run it. I'm just having to run, I have to run certain machines and then not, my words will come to me in a minute. I cannot run all my machines at once because I don't have enough power up here. If I run more than 2 or 3 machines and the beds happen to hit a heat cycle at the same time, it pops the circuit. Because this is only a 15 amp circuit into this room. So I have still yet to get off my butt and get the 20 amp circuit services put in place, but I need to. And once I do, then that'll make life a little bit easier, and I'll be able to run a few more printers at the same time up here in the office/studio. But I think a part of me was also saying, well, let's wait until we get the business going, because that could be a business expense. So, and we are starting that journey here very soon. The conversations have been had with the CPA. They're going to send me the forms so that I can file for standing up a business here in North Carolina. And that goes well with the conversations we've been having with Evocate as far as putting stuff on display at their shop and getting my name out here in the local community a little bit more. Because once again, the goal is to start moving this from being let's start using some business terms, a cost center of a hobby and into a side hustle that will then eventually be a, we'll call it part of the retirement plan, right? I don't want to be doing IT stuff and cybersecurity for the rest of my life. I've done that too many years of my life already. And while it has been lucrative, I kind of want my life back and just do the fun thing. Yeah. What I'm doing now is I'm just, like I said, trying to work these cables back in there and get our cable chain closed up. We'll have to get our, oops. We'll have to get our final link in over here and get this added to the bottom. Get this lined up and tightened back down. And this end's where you got to be careful that you don't get a wire caught in the mechanism, especially those pesky little black thep wires that like to get into places they shouldn't be. So what are you up to today, Lee Marie? You working on anything? There we go. One side in. Okay, we got both sides. Good. Both sides are in. We'll get that underneath there. Get that lined up. I have to tie that down. It needs to move over some. With this thicker cable in here, I'm going to try and move this over a little bit just so it's a little bit looser of a bend. That should work. This should work. All right, now we're back to where we need to cable underneath. So we'll have to set our printer down. Make sure we don't have anything in the way. Means get the phone and the coffee and the mouse out the way. Uh-oh, we got an ad break going on. Okay, so we're going to flip this up on its side. And I'll try and turn it some in the process so we can bring the electronics over here to the bench side view. It's always fun trying to figure out where to grab this when you've got lights and stuff on it. There's really not too many easy places to grab it. Okay. So we move this around some so we can get a better view of the underside here. So we replaced the board with the Leviathan. We've got our A and B motors down here to the high voltage side. So these can take a higher voltage. We can put 48 volts here for the A and B motors. That comes around and goes to our power supply. The inbound side goes to the power supply. This is for the bed, so it comes over here to the SSR. And we have another power cable that comes to provide power for the tool head into this Nitehawk board. So here's the USB-C that connects to the Raspberry Pi. This cable needs to connect right in here. So we'll have a little bit of cable to play with. Just run it down there, see if I can't get it into the thing down here somewhere. And then you'll see this wire here. This wire here is for the XY in stop. It was designed to go to a breakout board right here. Technically, I could put that breakout board back in here, plug this in, and use the XY in stop wires to come over and do it. But what I would rather do is keep that breakout board with the Octopus, and so there's the Octopus, there's the main board or the tool head board. Here's all of the under deck wiring. Here's the wiring that goes, all this black coiled wire is the wire that goes from the tool head to the under deck. And then this one right here is that breakout board at the bottom. So the nice thing is I can keep this all together, and this works for any like Voron style printer. So I want to keep this stuff together. I may sell this. I may give this away to somebody. We'll see. But for now, basically all I'm saying is I don't want to use that breakout board. So I'm going to have to do some type of pigtail for this wire here to extend wires out to the X and Y in stops. I can pigtail it, or I can, use the shrink down butt connectors to extend it, something like that. I mean, there's options there. I think I'm going to pigtail it. But this is going to come up. We'll bring it out and bring this out and just plug it in. Orientation, where are you at? There. So this comes in. I always love trying to line these things up when you can't see. There we go. Make sure that that latch clips. Now we've got a good solid connection. And once again, I'm going to extend these out, probably route it up around through here because my XY end stops are over here. Hey, Moji, how's it going? Now here's the other thing that is going to be fun. This says XY in stop. and there's 4 wires there. I have no idea which of those wires is what. I'm going to have to look at that board, that breakout board, and yeah, it does have it marked on the back side. I think the top side is just in stop. Yeah. So I'll have to take this board off so I can look at the pinouts on the back side, or maybe. Oh, I should be able to get right there. All right. Like I said, LDO, I love your products. They are great. You got to stop using red silkscreen on a black board. Okay, I think I am seeing grounds on the outside, X and Y is on the inside. And I need a Sharpie. Fine tip Sharpie. Fine tip Sharpie. Where's my fine tip Sharpie? Fine tip Sharpie. Okay. So it goes ground, X, Y, ground. So this is X, this is Y. I'll need to know that when I do that pinout. And what I'm going to need to do is create a 4-wire that's long enough. I'll do up 4 wires. I'll do up these 2 ends, and then I'll have to solder a 4-pin connector right here. Unfortunately, I don't have a crimp-on JST style connector, and I really want to get this up. I don't want to wait. Yeah, red text on black boards, it is way too hard to read. I mean, it looks beautiful. Don't get me wrong. These boards are beautifully made, but red text, red silkscreen on a black board, it's way too hard to read. They've got to make it easier to read on these. I will also say there is a 5mm shim. I have no idea where that 5mm shim came from. No idea. It came from somewhere. Don't know where. But for now, it's going to go right back in there. So I need to fabricate this cable, which is going to require some soldering. I thought of using my whatchamacallit connectors here, my microfits, and doing a pigtail. The problem is I only have the 2x2, and these are what's being used for the CAN bus, so I don't want to use the 2x2s. For the CAN bus cable, rather than having to use a UTC, this can be flashed for CAN bus. This is a CAN bus connector right here. There is a jumper right here for the CAN for the 120 ohm resistor. I'll need to put a jumper there, and we'll be taking a cable from here to the keystone jack. Whoops. Right here. This will be the 2/2 keystone jack. The female side is going to come in from the back side, and we'll put a screw here to keep it from getting pushed back out as we're trying to plug in our connector. And so our box turtle will be able to plug into the keystone jack back here using the 2x2, which means it won't be able to be popped over onto my other ones where I'm using the 1x4 connector that's straight sideways. So that's just a heads up of what we'll be doing there. I will put this to the side here. What I'm trying to do is just clean up this area over here because I am going to need to do some soldering. So I need to make sure that I've got room over here to solder some stuff. And then we'll have to figure out the length for our cable. So something also to be aware of is KB3D at Murph gave me 4 of the Nitehawk-SB boards. So it is quite possible that you will see other printers switching over to Nitehawk. Like the 350 Trident downstairs. The 350 Trident is currently got a box turtle on it and a Filomatrix toolhead. That's going to come off. All right. I know that's going to probably make Thunder Keys cringe a bit, but the plan for that printer is it's going to get a Cyborg CNC all-wheel drive setup. So it'll have 4 motors. All the parts on the gantry will be CNC metal, aluminum, and it's going to have 9mm belts. I think that's going to make it a little more rigid, being a 350 Trident. Might help my input shapers out. And it's going to get a takeoff 3D metal printed, I think it was FMJ, printed tool head with a tube. And when I do that, I'm not planning on putting a cutter on it. It's going to have, I believe I'm going to put an LGX Pro going into the tube. And I'm going to put, I've got a 1.0 nozzle that should be here this week, Undertaker style from West 3D. When that happens, that machine is just going to be dedicated to printing big stuff with fat layer lines. And yeah, that's going to be cool. All right, and this is not going to be long enough. Nope. We're just going to put that wire over there with the other wires. We're going to figure out about how long this needs to be. I'm going to probably go from here over and down. Once I figure that out, I'll cut 4 of them. Have a takeoff tool head LGX Lite Pro on order from Luke's Lab. Yep. So I've had this, I've had the tube and I've had the LGX since basically Rocky Mountain. So the history on my tube was I traded a Micron for a tube. And then I traded the salad fork for a Takato HE40 and a FXD extruder and a DFH kit. That DFH ERCFA kit is on its way to Petty Ruxpin, provided Mrs. Dragon gets to the mail today. If not, it'll go Wednesday when she's back out. But that's about good. Yeah, so actually I haven't decided. It may get the FXD, it may get the LGX Pro. But I have an LGX Pro, I've got the LGX motor, or not the LGX motor. Here we go, hold on. So I've had this stuff for a little while. I just need to finally get off my butt and get it going. So Takoto hot end, go back over here to the bench side. So Takoto hot end, this is the HE40, this is the long boy, right? You'll notice those heaters are pretty much all the way through, and they start right here at the top. These are two 100-watt heaters, and this is a super volcano nozzle. This nozzle comes up to about that far. It's stupid crazy. This is a, I believe that is a 1mm nozzle, right? So this is going to be able to push some major plastic, right? The extruders that I have here, this will be the pancake motor. This is the LGX pancake motor, the Bondtech extruder motor. This is going to go on the FXD. And then the other one that I have, this will go on the FXD and go on one of the hot ends. And then the other one is going to get this chunky bolt. This is the LGX Pro. And the LGX Pro, other than saying Pro, that's metal. This whole bottom, the mount is metal. And then you've got the nylon covering around it. But this bad boy will go on whichever one I don't put the FXD on. And the plan is to get some big printers with some big nozzles that can print larger things faster. And we may even be looking, and I've talked to KB3D, one of the things that me and Evil Diesel are talking about doing is designing and building, and it may be in conjunction with Ryan, who is the individual that came up with the Death Racers, the Mechanim, and then the Trikes. We all kind of came up with the same idea of we want a rideable Death Racer. Okay? So imagine you've got a trike. Now imagine that trike being either a tracked or Mechanim ride-on Death Racer size. Okay? If I'm going to do that, we decide to go Mechanim, then I need something that can print that full wheel size in a solid piece. I don't want to try and piece those wheel hubs together. Because then that's going to be a failure point. So when we go to do that, I'm going to need a bigger printer, which would mean either a Rat Rig 500 or a StableBot. And I'm pretty sure at this point it'll be a StableBot. Partly because I love my Rat Rig, don't get me wrong, love the Rat Rig, but I'm still waiting for shipment notification of my IDEX kit. And nothing against them, I get it, but with recent things in our election cycle, I'm not sure if it's going to drive tariffs or stuff against things like that. Now, I have a feeling that what we're going to have to worry about will be more of stuff coming from China versus stuff coming from the EU, but it could affect us one way or the other, right? So we just need to be prepared for it. Okay, I'm going to need 4 wires soldered to a JST 4 pin. Now, the issue that I have is my JST, I'll say my JST connectors that I can use. I say solder because I mean solder. The ones that I have are designed for surface mount, right? So they're JST connectors designed for surface mount. I have used them to make pigtails before. It's not the best because as you solder these pins, because there's no PCB or anything in the way, it tends to melt the housing, and then these pins kind of go everywhere. So you almost have to put a connector in here to make sure that the pins stay straight. I'm sorry, so you have to put a connector in this side with nothing in it, just a blank connector, and solder these very, very quickly to get your wires soldered to. So that's what we're going to do to create a pigtail here. So we're going to try and get our solder stuff out here and get set up to do some soldering real fast. Now the nice thing is, as far as trying to solder this up, I used to have like some really thick solder. This is a lot finer solder, which helps when soldering small things. It doesn't require as much heat to get this to flow, so that'll be good. I am going to move my stool over here and sit down while I do this because, you know, you got to get your face really close to the fumes to suck it all in. I'm kidding, folks. You're not supposed to be sniffing solder fumes. Oi, and hey, Shenanigans, how's it going, my friend? I'm going to put you folks on mute real fast while I blow my nose, so 1 second. Okay. Yes, I will say that I was inspired by Modbot as far as doing the tube and the takeoff hot end on the, well, he did his on his 0G Mercury 1, and I'm going to do mine on the Trident. No, I take it back. I think he did do his on his Trident. Right now I'm going to sit here and I'm going to get these stripped. Once they're stripped on the one side, then we'll get it prepped and ready to start soldering. And like I said, we want to solder very quick on this because in the blink of an eye, this connector, or the pins in this connector, will melt out. So I said I'd much rather have the crimpable connectors, and I'm going to be on the lookout for them. I'm not sure if KB3D just started stocking them. I think somebody did, but I don't know. If anybody has a line on where you can get crimpable female, where are we at? Female JST crimpable connectors and pins. So it'd be male pins, female connector. Let me know. I would be very interested in getting my hands on some. So all I did was I put a blank male connector in that female connector that's going to help keep these pins lined up. And we're going to have to hit it real fast with the heat. Thank you, Shenanigans. I know Evil Diesel was talking about coming by later today because he wanted to pick up some cookie CAD. He's going to be doing some ornaments, I think. He wanted to pick up some cookie CAD filament from me because I've got some red. I didn't have a good green for him, at least not in cookie CAD. All right, just like before, we're just going to tin these real fast. Once again, you don't want to leave heat on this particular connector because this connector will, the pins will melt and go everywhere. JST connector housings are not really designed for soldering like this. And once again, these particular JST connectors are designed for surface mount. So we need to make these connections pretty quick. One. Female pigtails are, well, the problem with that, Rob, with getting female pigtails that are already assembled is what happens when you need a pigtail this long. Most of the time your pigtails are going to be about that long, right? They're not going to be that long. But what if you need a pigtail that's like a foot long? That's where it's, you know, having the connectors and the ability to make custom cables is what I'm looking for. And good morning, Pez Liz. And you just subscribed for 17 months. Holy cow. Oh, what is going on there? Pulled my thing out so it wasn't getting hot. How are you this morning, Liz? I hope you are doing well. We are working on doing our pigtail to extend the XY end stops out. We've got the Nitehawk cabling from the tool head back to under the deck. And right now we're trying to create a connector like the other option that we would have would be to extend the wires themselves out and do a straight solder over there to the wires. And I would prefer to not modify that cable harness once again. Uh-oh, hype train, huh? Oh, wow. Well, there we go. Hey, Glendon, welcome on in with the 100 biddies. Good morning, everybody. Wow. Do a dance. Hype train. Do the dance. Do the dance. I'm not going to dance too much. But I will tell you, who was it that I was talking to? Oh, no, that was something else. I was like, there was a little dance I did on a recent call. It was a work call. Yeah, it was 6.5 hour work call at that ended at like 10:30 at night as we were troubleshooting some stuff. And yeah, got a little bit punch drunk on that one. But yeah, so what am I doing? I'm like, welcome on in, everybody. Shenanigans, thank you for the 100 bits. I really do appreciate that. We are wearing our veterans t-shirt today. We are, you know, I am a vet. I do very much like supporting veteran businesses and veteran causes. All of my military shirts that you see me wearing are veteran-owned companies, and yeah, it's just something I'm going to support and always will support. Black Rifle Coffee Company, you know, I drink a lot of their coffee. They are also a veteran-owned company that gives back to veterans through, well, veterans and first responders. By every time you order coffee, they send coffee downrange or to first responders. So when you see me drinking my Black Rifle Coffee Company, that's one of the reasons why I do that, is that's another way to give back. So thank you for the biddies, Shenanigans, and another 500 biddies from Glendon and another 100 biddies from Shenanigans. So thank you. Yes, love Black Rifle. Love Black Rifle. In fact, this right here is Tactisquash. So this is the Tactisquatch, which I believe was a dark roast. One of the other ones I found recently that my local grocery store is carrying is Fur Missile, which is an homage to the K9 units. Thank you, Moji, and I appreciate your service as well. You know, all of our former law enforcement agencies, Border Patrol, ICE, corrections officers. One of my neighbors is a corrections officer or former corrections officer, right? You know, we're all unsung heroes, right, to an extent, because we don't talk about it normally. We just do our job, we go home, and it's just another day for us. But what we do keeps people safe. It keeps our freedoms. And I can't find what I did with my snips. Not that I don't have a tray full of snips over there, but what did I do with the snips that I had here? That's slightly concerning. You guys see what I did with the snips? What I'm going to do is I'm going to do some heat shrink here to reinforce these joints and to protect them from any shorts. A little worrisome. Like, what did I do with the snips? Uh-oh, Cruising Girl. I'm not going to count that. I'm going to look over here and say Cruising Girl. Shared 40 bits. Thank you, Cruising Girl. Shenanigans with another 45 bits. Thank you. Uh-oh, we got a hype chest on the way. So I think, did the hype train end? Yes, the hype train completed level 2 at 49%. Thank you all very much. Check my pockets. Yeah, not on my pockets, or not in my pockets. Oh, there it is. There it is. Found them. Now we're going to put them right back there where they have been. Choo choo. Choo choo. If I can get my mouse in time, I'll try and snooze that ad for at least a couple more minutes while we continue to chat. Snooze for 5 minutes. Yay. 5-minute respite from ads. So what I'm going to do is I'm going to get this heat shrink on here and heat shrink this down. And then we'll need to sit down and try and do we'll pin the other side and get it ready for setting up our X and Y end stops. Speaking of which, I might have to create some labels for those because 2-pin or going from a 4-pin into a pair of 2-pins will be a little bit advantageous to have some labels on it. All right, so get that there. We'll angle this down some so that they don't kind of back off as we start the shrink process. Gravity will hold them down towards the connector. We're basically trying to reinforce the joint and prevent any electrical arcing or anything like that. That would be bad. That up there to cool off. Now we can either just mark the housing or get out and I think I'm just going to mark the housing. I'm going to be lazy. Now, one thing that we do need to do, let me bring up our browser real fast to bring that back up. Not the Leviathan board, not that. So what I'm going to bring up is this display. So this is the Rev D documentation for the wiring. And one of the things I need to look at is here's the X, Y, and Z end stop. We're not going to use the Z end stop because we're not using the little sex bolt plunger because we're using CNC tap. But we will have the X and Y end stops. And this is critical, right? Before wiring, the first thing you need to do is identify whether you receive the incorrect XY end stop cables. If you receive the incorrect cable, please follow this guide to repin the wires. The incorrect cables come with X stop, Y stop. The correct cables come with XES and YES. So this is the correct way that these get pinned out. So what I'm going to do is I'm going to bring my housing over here because once again we marked which is the X and which is the Y. The X is this one right here, X, Y. So the 2 pins on the left here are going to be the X end stop. The 2 pins on the right are the Y, right? So we just marked X and Y on our connector. And that's going to be critical because if you look, the X and Y connector are pinned differently, right? They are pinned differently. I don't know why they're pinned differently, but they are. So we're going to need to pay attention to that when we do our cable for plugging into the connector. Now, looking at it, it looks like the difference is the center, or the one pin goes into the center on the X, and on the other side it goes into the end. So my assumption would be that this pin down here that's common between these two connectors is going to be the common ground. We're going to need to verify that by looking at the Leviathan board. Do I have, I don't have the Leviathan board. This is the Nitehawk-SB. We don't need that anymore. Let's pull up the Leviathan and look for the pinout on the Leviathan. If we want schematic, I think we want the going to the manual, media. I think we'll just go into the manual. We should have a pinout in here somewhere. Ooh, you know what? I think I actually had downloaded that. Do it this way. It'll be easier to look it up this way than the other way. Keep that on the Nitehawk. So X, Y, and Z end stops. Make this a little bit bigger so we can see if it lists the what's what. So we have 3.3 volt ground PC1, 3.3 volt ground PC2. So that's a little, I'll say that's a little concerning, because this way, this would be ground. I'm sorry. Ground is in the middle. So the X end stop shows the PC, or the pin, and the ground is the middle. And then the Y end stop is the trigger pin and 3.3 volt. So I'm unsure. I don't know, that's just like a little concerning. Like, does it require? It shouldn't require. I'm going to pin these both the same way. Ground and the actual pin. I'm a little worried about putting one to the 3.3 volt. If it doesn't work, we can change it, but I don't think that in-stop pod requires power, because it wouldn't have been getting power before. Okay, so the pin that I just did is the actual, for the cable that I just stripped is the actual pin, so that's the trigger pin. And the trigger pin is all the way on the right side of that connector. Ground is in the middle. And these are going into 3-pin connectors, of course, so that's why we've got to make sure that we use the right connector when we do this as well. So this is the X. The pin goes on the right-hand side. And the ground for this one will go in the middle. How's it going, Cruising Girl? family friend suffers from severe PTSD from being in the RC. There you go. Yes. So I don't want to get into it, but I do have some friends that do suffer from PTSD. One of them was in a trench working on some things when they came under attack, and a mortar went off right next to the trench that he was working in and really messed up his hearing and some other stuff. So I had a few other people that went down in helicopters that came under fire. A few people that were leaving a zone, and they were getting mortars coming into the, onto the runway as they were leaving. So this is the X connector that I just did. So I'm going to write X on this on both sides. So that'll help me. Make sure that I put this in the right spot. We'll do the same thing with the other one. And once again, the middle connect, or the middle of the 4-pin connector here is the signal for the trigger pin. So that's the one that we're going to do first when we do the next one, which will be the Y. That way we can just keep track of which pin goes where. So yeah, it's a bit, this is the day to reach out and check on people, definitely. There are some other shirts you may see me wear that are from the Valhalla Project. And that really deals with the mental health, because we lose 22 veterans on average per day in the United States to suicide. Right? So if you know somebody, today is a really good day to reach out. Today is the day where it is the hardest for our brothers and sisters who are dealing with some demons, because and a lot of times it's survivor's remorse, right? They're remembering everybody that they lost and wondering why they're the one that survived, right? So definitely reach out to your folks today and just remind them how much they mean to you and those around them. One was X, this is Y. We'll just mark Y on here. And close that up before I knock it over and make a mess. The X and Y. X is on the right, Y is in the middle, Z is the last one and does not get anything put in. Once again, we went X, Y, Z is left undone. I am just going to double check looking at the silk screen on the board. And we do have these lined up with the PC1 and PC2 pins and ground. We have nothing going to the 3.3 volt, which is good considering looking at the silk screen for this, it was ground, X, Y, ground. So we shouldn't be going to any 3.3 volt. I don't know why it was showing a 3.3 volt on the schematics there, but I'm just going to lay this in there, come around, and that behind there, plug this in. That out of the way. How about plug these two in? Plug in. There we go. That goes there. This goes in this way. That's some excess. Plug that back in. Okay. So that's all done. We do need to verify our fans. I believe our fans are all 24 volt. So I do need to set the jumpers in here again for the fan, the two fan ports that we're using. We need to set those. We'll set these two. That's the hot end thermistor. We're not using the bed thermistor. Some of this stuff we're not using either. So I think we're close to being done. We need to set these two jumpers, and then we'll start working on software. So let me put away the soldering stuff. Get a couple other things moved around here. X and Y in stopper now in the jumpers. We need to do the jumpers. That's what we're going to do. We're going to scoot this back so we have some room right in here. Because we're going to have to be playing around some. The plan is I need to bring this online and pull the configs off of here, because this will have the configs for pressure advance and all that good stuff. Hey, Evil Diesel, what's up, brother? Yes. We've mentioned you a couple of times, so I hope your ears were burning. But welcome on in. Welcome on in. Hey, Petty Ruxpin. Petty Ruxpin, Mrs. Dragon has the box. Can't guarantee that she's going to make it. She's going from she has 3 different doctor's appointments to go to today. So provided she has time between the second and third one to run by, she will. If not, then she'll be able to run it out there either tomorrow or Wednesday. And as soon as I get the whatchamacallit, the tracking number, I'll give that to you. And if you would be so kind at that point to send the rest of the fundage, that would be great. Definitely don't want you to send it until I've got it on the way to you. Okay, so this is what we need. So this first one would be the Z probe, and then we've got 4 fans. The fans are 24 volt at I'll say the top 2 towards the EXP1 and 2, or if it's towards the connector, the middle and the down, it'd be 5 volt. All of these are 24 volt for these 2, as well as the Nevermore. So I need 2 of these to go in that. One there and one there. We're going to need 1 more of these for our 120 ohm resistor right here. I don't know if it's these pins or I think it's, nope, that works. So that'll work. We still need to do this connection to here. Where is that cable? Right here. So I've got this side done, and I did verify that the UTC CAN bus cable and this one are the same pinout. So this will literally plug in here, and it's going to come straight across and go into another one right here. So I just need to figure out that distance, and then we'll be able to make this cable. You know what? I'm just going to do it like this length, and I can kind of bend it around out of the way down here just to make sure that it's good and doesn't have any, so that we don't have any, or if we have to repin it for any reason, we can. And Evil Diesel, let me know when you're ready to come over, and I will get the, I've got that filament for you downstairs. Okay, so what do we got? This isn't imperative to have in place just yet. Not imperative to have in place just yet. I'm just thinking to myself real fast before I go plugging things in and powering things up. But I think we're good. Like I said, I want to bring this up, and I need to pull the configs off of it. And then we can shut it down. We're going to pull the SD card, and we're going to basically start from scratch and redo this whole thing. All right, so we'll redo the Raspberry Pi. We will flash this board, and we'll flash it so that we can use the CAN bus, and then we'll flash the Nitehawk board as we need to. Yeah, and we'll basically just run through that stuff. So if we come down through here, I believe we've got everything cabled out. There would be XYZ. Actually, I think at the final bit here, there is the final high-res image. So we'll just come in here. Now the orientation's off because, of course, this is a Rev C that we're modifying. But the big thing is looking at the Leviathan. We've got Z end stop. We know we're not using Z end stop. We've got Y and X. We've got the bed thermistor, no tool head thermistor. We've got the two fans, one going to the side and one going to the Nevermore. We've got the LED strip. We've got our four Z motors and then the A and B motors. Network jack. And the power coming into here for the high voltage, the display cable. We've got our Nitehawk board with power coming into that. There's our USB-C, and then our USB coming out and going out and about. So that's all done up. Our SRR is the same. The SRR, once again, is connected to the top connector here by the CAN bus. The lower one is the main power coming in from the PSU. And we've got this board cable connecting over here to provide power there. So I think we're good. I think we're good. We're in a position where we can plug in a power cable. Now to find the power cable that is back here. And is this going to be long enough to go around? Probably not. Okay, what do we got here? I think. I need like a 20-foot power cable. That's not sketch at all. Not sketch at all. Bring this around, plug it in. We're going to flip the switch and hope that we don't see any magic smoke come out, right? Fingers crossed, no magic smoke. Double, triple check. Ooh. Good thing we double, triple checked. Here, let me go over here. What do we see wrong here? You require a lot of coffee today? Yes. We require lots and lots of coffee. I am glad that I looked at that because that would have been not good. Don't know how that happened, but that's not connected at all. Which is really weird because I was pretty sure that I had done the pull test on that. What is going on there? Fully backed out. Sorry about getting my head in the way here, folks, but got to do what we got to do. Make sure that this connector is definitely good. Okay, that is definitely good. I do want to make sure that looking at this, red is at the bottom, black is at the top. Red is at the bottom, black is at the top. Red is at the bottom, and black is at the top. That's good. Red is at the top, black is at the bottom on the other side. Which is what it looks like. I will double check that with the Leviathan board. So the VN red is towards the center, which it is. Black is towards the corner, which, so this is a bit concerning. Over here looking at the full display, right? This shows black. This shows red. This says VN 2448 at the top. That's the black line going into the negative. That's these two lines should be switched. It should be HV steppers up here and VN 2448 at the bottom. Yeah. That's see, this is why we double check. This is why we double check. Once again, we've got color codes. So power, ground, and signal. So we see signal and ground, power on this side. We're all good here. Yep. Thermistors don't really matter. We don't have a NeoPixel directly in here because we're using just straight white LEDs. Okay, now I think we're good. We've got good connections here. These connections are nice and good. These are all screwed down. They're covered up. So now I think we're good. We're going to go ahead and let's go bench side. I guess well, no, I can't go around there now. We'll hope and pray. Okay. Nothing go boom. We got lights everywhere. We got lights down here. We got lights here. Got some lights there. Lights over here. Lights over here. We've got a screen that's coming up and doing its thing. Now, this will fail in the boot into Clipper because we've got a completely different board, right? It doesn't know how to talk to this board. So it will fail that part. Yeah. Coffee, human. So we've already finished 1 cup, so 20 ounces there. Now we're going on to cup 2. You think you need some alcohol already? Yeah. There you go, Rittenhouse. You got your 2.4 frame started yesterday and the linear rails clean, lube, roughly mounted. Okay, good. Yeah, not enough coffee for a holiday like today. And yes, me and Evil Diesel are both non-drinkers anymore for reasons. But lots and lots of coffee, fortunately. You've only got 2 more hours of meetings left before I can start working on your action. And see, there you go. I'm off today. That's why we're streaming. The plan is to stream until this is pushing plastic again. So Clipper is up and it's still trying to connect. So we should be able to hop over here and this is Kyber Dragon. That's not what I want. It is, but it. Yeah. So as you can see down there, we're airing out as it's trying to. There we go. Finally aired out. It can't talk to the MCU. That's good. We just need to come into the machine, and I'm going to download a few things. We probably don't need adaptive mesh anymore, but we'll download it. Line purge, we'll download that. We'll download the macros. We'll download the nozzle scrub. Printer config. And the stealth burner LEDs. So we'll need that stuff when we redo this, right? We may not need the adaptive mesh and the line purge. I believe that's built into Clipper now, but I don't know what I might need to do to get that fully set up. So we've got these downloaded, but let's double check. Oh, wait, no, we actually didn't download them because it wants me to say keep, because for whatever reason, Windows is like, you know, config files could be dangerous. So we've got to keep them. Now, did these actually download? Seriously. I have to say keep and verify every single time. This is annoying. Windows 11 and Chrome, why do you got to be a pain in the ass? Okay, it looks like everything should be down. We're going to go ahead and check our downloads folder. We got adaptive mesh, line purge, macros, nozzle scrub, printer config, and stealth burner. So I think we're good. So we can shut this down now. And we're going to get ourselves started on reflashing everything. So with that, we're going to need this, because this will be our USB cable that's connected. We're going to need a USB reader. And I don't know if I need, I'm not sure if I'm going to need one of the 128 meg ones to flash the Leviathan or not. We should be good now to shut off. We're going to power down. We're going to pull the SD card from here, which will be a little fun. Best way to do that. They need these SD cards to be like push in pop, you know, like the spring loaded ones. There we go. So I tend to use SanDisk Ultra 32 gig cards for these. So this is what just what I've always used. We are going to put this into the little SanDisk reader. We'll plug this in. I should hear my board do noisy things. And what we're going to do is we're just going to come back here. We're going to follow the software setup. Yeah, SanDisk are great for their warranty. You have to be very careful though, because if you buy your SanDisk from reputable places. Unfortunately, there's a lot of sellers on Amazon. There's a lot of sellers on eBay that are selling counterfeit. Be careful, be warned. Make sure you buy them from a reputable place. Okay. Have I made a filament respooler? You mean like filamentalist, or are you talking about one that you can take it from one spool to another, or go from like a 5 kilogram down to a standard one or whatever? Because I have printed one of those off, and the only issue that I have is the printable like arm that you attach the handle to tends to round over after, you know, once you get a couple of spools done. You wind up printing a bunch of those and redoing them. But I do have one there. I'm probably going to look at a couple of others as well. So the Raspberry Pi OS, the easiest way to do it is to use the official imager. They suggest doing the standard Pi OS Lite and then doing Kaya, which is what we'll do. You can do the mainsail OS, but I'm going to do the Kaya route. Raspberry Pi imager. I have that on my desk. Does not appear to be on the desktop. So bring that back up. Click over here and we'll go find the Raspberry Pi imager. And I'll go over to full display for this while we're doing it. The Postomatic takes 14 608 bearings. The one that I've got, I'm not sure which one this is. So this is the one side, and I do have a couple of the different center hubs, and then this is the side where you're going to be pulling from the other spool onto this one. Your crank handle would go here, but like I said, this tends to round over, right? But you got 1, 2, 3, 4, 5, or no, 1, 2, 3, 4, 5, 6, 7, just on this piece. But it does go back and forth based on when you're cranking it, so it does wind it side to side as well. Yeah, this one's various places, Maker World, printables, what have you. But that's the one I've been using. Like I said, I'm probably going to reprint it with some different materials, but okay. Any major differences in those OS builds? So just doing the straight Raspberry Pi Lite image is the less overhead, right? You're doing basically the main server build. So we're going to choose the device. You can choose the device. This is what is this? This is a Raspberry Pi 3B Plus. So we'll find the Raspberry Pi 3, choose the OS. It's said to use the 32-bit, but we want the 32-bit Lite. So Bookworm, this has the Raspberry Pi desktop. This is with security updates and desktop environment. I don't want that either. So we're going to click on the Raspberry Pi OS Other. Okay. This is OS Lite. This is basically the headless server version, right? But that's 64-bit. This is 64-bit, and then here's the 32-bit. You have OS Lite 32-bit and OS Full 32-bit. The Full is, of course, has all the desktop and menus and stuff like that. It's just heavier weight. There is the older version. This is Bullseye. This is Bookworm up here. We're going to take the latest version. We're going to choose our storage. We're looking for that 32 bit or that 32 gig card, but nothing's showing up. Something finally showed up. This is a 250 gig one. We don't want that one. Definitely not. So why is our USB not showing up? Why is our USB not showing up? I guess it might be worthwhile to double check and make sure that this USB cable is even plugged in. Let's double check that. Oh, hey, it'll probably work better if the other end of it's plugged into the computer, huh? Let's make that happen. And look at that. There's a SD MMC USB device that's 31.9 gigs. That's a lot better than overriding the 250 gig hard drive. We'll say next. It will ask us if we want to do some of our, do we want to include all of our settings? We will come back to this. Make sure my screen is not being shown. I want to verify what these settings say. All right, we're dragging Pi. Make sure that that goes back to being the default. That. US, America. Time zone, SSH with password. Okay. So we are starting that write process. While we're doing that, yeah, you're all about easy maintenance, so less moving parts, the better. Yeah. So, and that's one of the reasons why we just went through and did all the pain that we just did, right? Was we swapped the tool head board from the standard board with a 14 wire and 2 wire cable that went all the way back down through to this one 6-pin USB cable with power, right? So that's going to streamline everything at the tool head. The other thing is we switch, and that means less wires here. Like I can tell you, come back to the bench set. So this was the cable that went through the cable chain. This was the breakout board that used to be right here. And then all of these wires over here were the wires that went from that breakout board back over to the Octopus board, right? So a lot more wires in place. While it was very simple, it is fairly easy for maintenance. Without having it's basically a dumb tool head board, right? So we had a breakout board here that was just taking multiple cables into a single cable connector that routed all the way up. So it was very long direct cabling. With the going to the Nitehawk-SB, the Nitehawk-SB now has a MCU on the tool head board. It's going over serial, which is actually better than CAN bus because it's got a larger throughput bandwidth, right? And it's a little bit simpler to talk over rather than CAN bus. So that's actually a little bit better. As you see, our wiring here got a little less convoluted because everything that's on the tool board stays at the tool board. There's one wire that comes back and that's it. Nothing else comes over to the main controller. Now the nice thing with this is a 200-watt power supply. If this is not good enough, I can just swap this out, put a 350 here, and I believe it's the exact same size. And that will definitely cover us because remember, yes, so this is an LRS 350 and same footprint, right? So if we have problems, because remember, mains heated bed, so through the SSR, this is only running the tool head and the electronics underneath here, but we're going to be connecting in a box turtle. I don't expect there to be any issue. If there is, though, we can swap this out for this. It's a direct swap. Everything is still easy peasy lemon squeezy. Okay. Jarvis Winder uses a microcontroller. Interesting. Yeah, my thing is I'm fine with a hand crank, right? And like Evil Diesel said, I like the easy maintenance. I'm fine hand cranking it, right? It takes just a couple of minutes. And I know people will jack in their drill and wind it with a drill. The problem is I've found when you go really fast, when you're doing that wind, it gets a looser wind, and that could lead to more problems down the road. Right? Okay, so while we're waiting for this to do its thing, well, it's almost done. But we will go ahead. We do have some heat shrink on here for this side. We're going to go ahead and trim off an end of this so that we can get started on this side of the equation. And once again, this is the standard CAN bus cabling. I just keep using, when I trim it down to side, I just keep using the excess to do the rest of my wiring. So like the underdeck wiring. And I kind of want this to be a direct pass through. So the end of the cable is going to plug into the back here. I want it to match this 100%. So I'm going to look at this, and when I'm putting this into the female connector, I want to make sure that it's a direct pass through. So positive, negative on the bottom. Yeah, this is basically going to be, wait a minute, let me, yeah, that's basically how it's going to be wired up. And we'll go ahead and start getting this figured out for the female side of these connectors. Going through and it's doing the verification on this. Okay, so this is going into the female housing, which means it needs the male pins. Okay, our Raspberry Pi imager is done. We'll click continue there. Close that out. Our external drive is connected. I don't want to scan that for threats. Insert the SD card provided in the kit. Choose the blah, blah, blah. Remove the SD card from your computer and insert it into the Raspberry Pi. So, let's make sure that it's ejected. And it is. So we can remove our card reader. And we'll take our SD card. Once again, the SanDisk writing goes, I'll say, away. So you want the black side with the gold pens. And that's going to come up here underneath. This might get fun to insert. And I get it partway in, and then I kind of do the front, back, side to side to make sure I'm in the socket and not on top of the socket before I push it in. Because if you think you're there and you push it in, it's going to fall down, and then you've got to dig around. Oh, no, I don't trust Windows to auto-eject a darn thing. So now we're going to need to turn this back on so that we can get our Raspberry Pi to come back on. And we will access the Raspberry Pi. So here's the thing. It's the same MAC address, right? Because the MAC address is the physical address either for the hard port, the Ethernet port, or the Wi-Fi, right? So this has a MAC address. Your Wi-Fi controller has a MAC address. I have set up a static IP based on the MAC address mapping. So this is going to come up. It's going to be the same IP address. The only issue, I got to fix the screen because it's upside down. So it's going to pull the same IP address is what I'm trying to get at. Is once it talks to the Wi-Fi router, it's been assigned a static IP address mapped to the physical address or the MAC address of the Wi-Fi controller. So I should still be able to get to the interface, no problem. I do know when I go to SSHN, chances are it's probably going to throw an error because it already knows it, but it's going to have a different key credential. I'm just waiting. I'm watching the screen here to make sure I know when it comes fully up. Meanwhile, I'm going to go ahead and get this. Okay, it is fully up. Or no, not fully up. Working it. Came up and then it rebooted. So I think, yeah, the first time it comes up and it does a reboot, right? Because it's redoing the, like expanding the file system and stuff like that. Yep, and it came up and it did pull an IP address. Let me get this wire crimped here, and I will jump back over and we'll start the next step. All right, and the next step will be remotely accessing it via PuTTY. PuTTY, it is 192.168.10.77. Digital security breach, I'm good because I know I just redid this. We're going to log in as Pi and Raspberry. Okay, and the first thing we do, sudo apt update. So what it's doing now is it's updating the repositories that it can pull, that it's aware of, so that it can pull the upgrades. And once it gets its list of packages from these update servers, then we can actually do the upgrade and tell it to actually upgrade everything as it stands. Always the best thing to do when you first do one of these. So sudo apt upgrade. Going to come up and say, here's a list of things that you can upgrade and how much space it would take. In this case, 102 megs. We're going to say yes and let it start updating. Now we're going to come back and continue to work on our cabling. And this is the same as we did the other connectors. It's just using a different pin, right? So one has the female connector. This is just the male connector, which has the, like the single pin coming up out of it. The only difference. And on the bigger, thicker cables here, I'm going to get the wire or the connector on the wire and then crimp it in place. For the smaller ones, it'll be easier to get the connector in the crimper and then slide the wire in. Here's our two bigger cables done. And once again, we're looking at the cables. I want to be able to replicate this end of the cable in the same exact manner. So bottom left on this connector is going to be red. Bottom right on this connector is going to be the black. So I will get the red to the left, the black to the right. And make sure you know where your clip is, right? So once again, here's the clip. We're going to make sure that our locking clip is in the same orientation. So this bottom side here is going to be red. This bottom side over here is going to be black. I'm going to pull that connector. I'm going to make sure that the red is on the left, the black is on the right. And we're coming in from the back side of the connector. These lined up, split in. Make sure they're fully seated in there. And that they're locked and not coming out. So we're good. Now that we have our red and our black done, we know that yellow is our high and green is our low. And the high goes over the red, the green goes over the black, and it makes it a little bit easier to get these two done. And we do want to make sure there's at least one twist in this gap here. And once again, that's for EMI. reasons. And once again, it's still doing its upgrades, so I'll keep it over here while it's doing the upgrades. It's like not... Watching it do upgrades is like watching paint dry, so... So, one other thing to note is we're using TMC 2209 drivers, right? And the versions that we have, I probably should have put these in, are 1.2, right? We talked about that and how that could be problematic because I've had intermittent issues with 1.2s working with some boards. And I have some 1.3 driver boards that just came in today. So, or yesterday. So I do have the 1.3s. I can swap those over if need be. And the 1.2s aren't working for whatever reason. Like I said, I don't know why they have issues. I just know that they do sometimes. So if I encounter any issues, I'll just swap those drivers out and it'll be easy peasy lemon squeezy, basically, right? So, okay, our updates are done. Let me go ahead and finish this one pin out and this pigtail cable will be done. All right, and that is in there. So I will pull my shrink wrap up and shrink wrap this real fast. So that end's done. Now we still need to do the other end of the box turtle cable, right? We had left that one undone, so still need to do this one. We can do that. Ooh, interesting. Interesting. Because the interesting thing is this side, which goes into the ASC, is a different pinout. The red, black, and stuff are on different sides, so we're going to need to keep an eye on that. That's why I definitely like doing different connectors, so I can't take this cable and put it in backwards, right? That'll be something I'm going to have to try and figure out how to identify that. Now, you love watching updates like I used to watch the drive defrag. Oh God, yes, Evil Diesel. Love that. Okay, so our updates are done, right? Now we need to do some things. It's like your Raspberry Pi will need to install the OS Lite Clipper and a web interface. They suggest using Kaya, though you can do the mainsail OS. We're going to go ahead and bring Kaya up. And it's pretty simple. We're going to copy and paste some things over. So we don't need to do the update. Well, we do. We need to install Git or make sure that Git is installed. So we'll copy that. We'll paste that in, hit enter. Going to run through and make sure to get the latest update repos again, and then install Git. If need be, and it looks like need be. And then the next step is going to be to clone down the Kaya software. So we'll make sure and get that copied so that when this is done, we can right click and get that going as well. Sorry, folks, 1 second. Trying to work on some cabling. So we'll copy that over. And once again, this is going to clone down the Kaya software, which goes pretty quick. And then we're just going to run Kaya. So we'll copy this next line, come back over here, right click, hit enter, and it's going to come up into the Kaya interface here. Now, it starts off saying, would you like to try out Kaya 6? Which has been completely rewritten from the ground up. It's still in alpha. So bugs may occur, get your feedback and blah, blah, blah. So we're going to say no, because we don't want to have any issues that we have to just try and track down. Now, we're going to start off, we need to install stuff. So we're going to go 1 to install. And basically, we're going to start from the top and work our way down. We need Clipper and Moonraker. So we'll go 1 for Clipper. Select the Python version. We want to use the newer version. So we'll take the recommendation. Number of Clipper instances, it defaults to 1. That's all we need. It's going to go through and start its install process. And as we continue to work on our cable while this installs, we're going to be going into the male housing with female pins, right? Male housing, female pins. And what I'm trying to do right now is just make sure I get the thicker wires pointing in the right direction, because I'm not going to have enough room to like be crossing these over and all that goodness. Rotating them and stuff like that. So you want to make sure that these are lined up in the way you're going to insert them, because it'll go in a lot easier if you can get them lined up ahead of time. Oh, and Evil Diesel, are you chaperoning that dance we were talking about? For your daughter? Because that would be pretty funny. She'd probably lose it, but maybe you should. Yeah, that would be pretty. That would be pretty funny. Like, you get a choice. I can chaperone or your mom can chaperone. Pick your poison. And I'm not showing you as I'm making this cable, because once again, it's, as you make this cable, you're going to have to be working on it and being very, very meticulous in getting your wires set up in the right direction and orientation. And it may be different from the way my cables are being done. So, and if you've got so I'm making pigtails to make it easier to go in and out, right? When you get a kit from LDO or even Isix, you're going to have a long cable, right? That's it. You're just going to have a long cable. It's going to be terminated on one end for the AFC light, and chances are the other end is going to be terminated standard for LDO, which would be a 2-pin JST to go into the can high and low, and then the 20 or the spare wires for the power to be plugged into Wagos or what have you, right? I am choosing to do this just because it is going to make it easier for me to transport, because I can take the box turtle off the printer this way and transport them as 2 separate pieces, and then put them back together at the far end just by plugging one cable in and PTFE tube. If you've got a more stable setup, there's no need to go through this much pain. By more stable, I mean you set it up and you move it maybe once a year. But these are going to be at shows, on display, moving around, having the ability to separate them or take them apart if I'm going to be doing maintenance or upgrades or what have you. This is more quality of life, thinking ahead. Adds more pain to the process, but that is the choice that I've made for myself. And that's the thing about open source and open source designs, is we get to make changes that we deem fit for our purpose, right? Some of the other stuff that we can do, actually, no, we're gonna wait. We're gonna stop messing with that. We're gonna be working on getting this configured and done. Yeah, as I mentioned before, when I was over at KB3D for their open house, I had purchased a bunch of 3-pin connectors specifically for box turtle lighting systems, right? And then I get home, and as I'm trying to figure out our cable here, was when I realized that normally on the pass-through, I'm using a 1x4, meaning 4 in a row like this rather than stacked on top of each other. And I'm out of the 1x4s. So I gotta buy some more of those. And of course, I have a bunch of them in my cart for KB3D. A bunch of them, right? $11 in connectors. I go to checkout and shipping's going to be $19. I was like, no. Either I've got a message into him to see if he sees it. Because he's going to be shipping me something, I believe. And if he does, then I want him to just throw those into it and ship it all as one. If not, then I'll figure something out. I may have to like purchase something else. Let me see if he responded to me. Nope, not yet. So Chris 2, you wholesome dude, you. If you're still there, tell Breezy to look at his Discord DMs. Inquiring minds want to know if he is the one shipping me the item from LDO Motors. Services are better when it's easier. Yep, service is better when it's easier. Plus, it makes it easier to repair. Yeah. So that's the thing is the harder it is to do maintenance on things, the more apt we are not to do the maintenance. If it's really easy to get in and do maintenance, then you're going to do the maintenance that you're supposed to, right? Oh, it's the 1x4, the 1 row 4-pin microfit threes. Those are the ones that I'm out of. Those are the ones I normally use as my skirt bypass or pass through for the box turtles. But I'm fine with this one being different than the rest simply because this is going to go on display and this is a match set, right? I've built the box turtle with the same color scheme as this printer. That's why you haven't repaired the bamboo door hinge. Is it something that you actually have to take the side panel off to fix? Because I thought the door hinge was actually fairly easy to get to. Oh yeah, yeah. If it was the post piece, then yeah, you're having to take parts off, aren't you? And that would be, you know, like there's a couple of things. Like I've got the parts to put a chamber heater in my bamboo that I use to print both or print most of my more engineering materials. Like one is pretty much Dragoon 2 has been pretty much PLA, right? I do some other stuff on it, but it's primarily been the PLA machine. The Dragoon 1 has been primarily a high temp enclosure machine, right? So on that one, I do have a chamber heater for it, so I can work on some straight polycarbonate and things like that. Hey, Creative Brit, how's it going? How's it going? I'll put it over here and say, welcome in, Brit. How are you? Hope you're doing good today. It is Veterans Day. I am off work, and damn it, that main camera froze again. What is up with that camera? Like, it's not that it's hot, or at least I don't think it is. Now I'm getting upset because it does that, and it normally winds up being because of some darn Windows update that it just kind of, that one, and it's just the one. Like the camera up here and this camera are the exact same. They're the exact same cameras, right? That one hangs, this one doesn't. And I know what it is it's the, they're the Brio 4Ks, which have that, I think it's an Intel chipset in them that, or Intel or Broadcom, one of the two. And they have known issues. And I don't know if I unplug it and replug it in, if it'll come back. I'll see if I can get over here and unplug it and plug it back in at the back. See if that'll do like a reset on it. Nope. It's dead as dead as dead. So don't know why, but that's annoying. Intel, yeah. Um, the foot's feeling okay. If I'm up on my feet too much, it will start swelling. Well, it swells throughout the day anyhow because I'm vertical or in a seated position and it's not elevated. But it is getting better. It's just a slower road because it's a big toe. It's great because I'll go in and I'll take a shower in the morning, and that's when I realize how bright it is. And it's really like the entire toe joint. So from the toe joint into the foot itself is fine. But like from right there to the end of the toe, it's just like a red. And it always shows up even more red after taking a shower or whatever. But it's good. At least it froze in a great spot. Yeah, that's right. I mean, it's looking at me. Nothing's moving, but it is what it is. Yeah, I have a OBS bot camera in my cart. I just haven't pulled the trigger on it. Partly because I'm going to wait until I get the business entity created, which I need to reach out and have my CPA send me the forms. I know I can do it myself, but I'm going to go through my CPA and have it all done. And once that's done, then I can go ahead and purchase it because it's like a $300 camera, but it tracks you. It has a good zoom and stuff like that. It's got gestures and voice control, which should make things a little bit easier. Let me go back over here because we got a question here. It says, your current user is not in group TTY. Do you want to add it? Yes. But yeah, once I get the business entity up, I'm gonna set up like a separate bank account, all that good stuff, and it'll become the business expense, and I'll just purchase that. Okay, so we're back at the main window. Clipper has now been installed. So we just go to the next step, which is Moonraker. So we'll hit 2 and enter. Install Moonraker. Well, yes, that's what I just told you to do. Yeah, it's an Intel thing. But that's the thing is, why is that one freezing and this one not? That's what doesn't make sense. If they both froze, I would get it. But why is one freezing and one doesn't? I don't know. Yeah, Intel gets updated constantly and it breaks every time. Exactly. But I'm gonna put the OBS bot on the main camera up there, and then I was thinking if I could get the damn Brio to be reliable, I would put it as the overhead camera because this camera is the 922, which is 1080p only. And I think being able to go with the 4K camera, if I can get it to do that, it'll be good. Intel Gen 3 chipset. Is Intel controlling your USB bus? This is a AMD board. It's an AMD system. In fact, somebody asked me about that. I did update. If you go into the about on the stream, one of the panels is my PC, and it's got the loadout of my PC. But I am running. What am I running? I can't remember anymore. Huh. Apparently, let me go find the app that I have that tells me what all my stuff is. Once this pops up. Okay, so I am running a AMD Ryzen 9 5900X. And it's 12 core processor with 24 threads. It's a Gigabyte B550 Aorus Pro AC. And so I'm actually running 3 M.2.5 SSD drives. And then I have another SSD drive and a spinning disk for latent storage. We just upgraded the memory from 32 to 64 gig. Graphics card is an NVIDIA GeForce RTX 3060. So, and I am thinking, Evil Diesel, that the 120 all-in-one cooler, probably not the best. I'm thinking I'm gonna grab the, was it NZXT? I think is the cooler that I have in one of the other cases. It's a 240. I may pull that one off and put it over on this one. Put the standard air cooler on the other one. I don't know. We'll see. If I do that, I'll give you the 120 for your daughter's computer. Have I updated the BIOS? The BIOS on this is where? Which BIOS? F18 Bravo from July of this year. So it may be the latest. It may be a little off. I do know I had to update it in order to update the CPU. So yeah, I did have to update it to update the CPU on this. Looks like Moonraker is now complete and we're back. So next up, we need to choose either mainsail or fluid. I prefer mainsail, so that's what I'm going to install. Though funny enough, I say I prefer mainsail. I've got a rep box now in the black box, and the positron uses fluid. So you love your custom closed loop? Yeah. Evil Diesel does closed loop. So he's got a custom closed loop on his big rig. So yeah, I'm running, I want to say I'm around 50C right now with everything it's running. Let me pull the darn thing back up. And what's this asking? Recommended to use? I always say yes here. Just gives you some default macros. And we're back. We do need to add clipper screen, so we're going to go ahead and do that. Actually, hold off. Let me hold off on that for 1 second. Where are we at here? So, yeah, we're holding at 53C at 5% load on the processor. I mean, it's not bad, but I know it can be better. And if I fire up Fusion 360 and start doing a big model, it's gonna chug out some more. So where were we at here? Pull this back up in the background. Go to the Kaya because we don't need that anymore. Follow the previous step with Kaya, then Clipper screen should be successfully installed. Read this guide for information on setup and rotation. We will need to do that. So let's go ahead and install Clipper Screen, which is number 5. So we'll do 5, enter. This will start setting up Clipper Screen. So, hey, Miss Lee Marie, how are you? Happy Veterans Day. Hey, Bear, how are you doing? I doubt this is it, but sometimes Windows will kill power to USB devices to conserve power. I had a NIC once that had issues, and I had to tell it to not manage power on it. True, that could be an issue. But I mean, it's giving an image, which means it has power. It's just not shifting back over, which is weird. Like, once again, I'm going to switch over to the main camera. No, the camera's back. What the hell? And then now it's gone. It just froze again, right? So I'm clapping my hands, no movement. So I don't get what this darn camera is doing. It annoys the crap out of me, right? So this one's still working and moving. The other one craps out. So I don't know if it's where I have it plugged in and as to which controller it's using or what the deal is. No, these are USB cameras. They're Logitech Brio 4K cameras. Whoops. Checking the Python version. Python blah, install standalone. It will create a service, enable boot to console, and install the graphical dependencies. Say no to install as a regular desktop app that will not start automatically. We want this to be yes. We want it, this is a standalone printer. We want it to go into Clipper Screen off the get-go. So we're going to say yes, install it as standalone, and make it go into the graphical interface automatically. And yes, I want X server. I don't do Wayland. Once again, Wayland is experimental. I always use the X server. So we'll put X, hit enter, and we'll go that way. And yeah, it's not hooked up to an HDMI capture. I'm just using straight Logitech Brio webcams. And then the overhead is a Logitech C922. So, what was I coming over here for? There was something I was going to come over here for. Oh, I know there was a reason I was coming over here. So, you guys have seen the Digital Dragon in his current glory. Here is Digital Dragon, circa 1993, in BDU and Blues. This is up in Alaska at my first duty station. And yes, folks, I had hair back in the day. The Dragon did have hair back in the day. Better looking these days. More power and with, yeah, yep. Oh, thanks, Miss Lee Marie. Yeah, there's a saying that I have that I've used on several web pages in the past and stuff like that. But you know, I go by Digital Dragon. I've loved dragons since I was growing up, and my aunt introduced me to The Hobbit, and then I got into the Lord of the Rings, Dragonlance, Dragon Riders of Pern, the whole thing. So I've got lots of dragon tattoos and stuff like that. But I always say the strength of a dragon, the wisdom of its years, because as you know, dragons are long-lived mythical creatures. They are very strong, but they are also very wise. Yeah, D&D nerd. Yep, basically. Though I've never really played D&D. Like the first time I have played D&D was with Evil Diesel earlier this year. The first time I've ever played a real D&D game. You know, you will this Friday? I will what this Friday, Evil Diesel? Yes, my birth year is 72. That tells you that I am an older dragon. I do have the wisdom of many years underneath me. So are you saying that we're going to play D&D this Friday? Let me check my calendar. Yeah, I'm good this Friday. And I say check my calendar because literally I have to. Oh no, what day is that? One of these days coming up, I can't remember which day it is, but we're doing like a organizational event. Kid wants you to join us for D&D next Friday night. Forgot about the dance. Okay, so this Friday, the 15th, is the dance, right? And then the following Friday, which is the 22nd, is the date that you're saying come over and do stuff. Okay. Yeah, because it's the following week after that that's Thanksgiving. So, oh wait. The dance is the 15th, which is this coming Friday. And it's the following week, which would be the 22nd, that you want me to come over and do. Okay. Who all is going to be there? That and send me a reminder, calendar invite or something. I will forget. Hell, I don't know what tomorrow's bringing. How often you lubricate your rails with EP2? Once a year, twice? So honestly, Bear, um, I pack the crap out of them with EP2 when I build the printers, and then I kind of forget about them until something makes noise, which is not a really good way to do that, by the way, folks. We were just talking about printer maintenance. Like right now, I should be like trying to take an end off and squirt some grease in here, but that's the problem. Is a lot of our carriages do not have grease ports on them or working grease ports on them. So, and there's no real way of getting grease into the grease ports without taking the rails back off, which basically means doing major disassembly. Do I do printer preventive maintenance? Yes. Like I will take and wipe these rails down now with or I have with the 3-in-1 PTFE oil. Just get a couple of drops on the rail and wipe them down. And the reason I'm doing that isn't to lubricate the, I'm not lubricating the bearings in the carriage. What I'm doing is getting a light coating of oil on the rail themselves to prevent any rust. Because some of these rails that you get may not be stainless steel. They may say they are, but I've seen rails rust. I have seen rails corrode if you use the wrong type of carbon in your carbon filters. Like, there's a reason you get Nevermore or a good quality. If you get the ones that have chlorine in them, it will destroy every fastener in your printer, to include your linear rails. But yeah, if I'm taking the rails apart, so case in point, let me go this way. Bay Dragon, this 2.4, right? We're going to be doing some maintenance on this soon. And by maintenance, I mean, I'm going to take I've got carbon motor mount plates and carbon rods on it, right? It's the Chaotic Labs carbon setup. I like it, but I don't. I'm also thinking about getting a 9mm belt set and all-wheel drive for this. It's at least going to go to all-wheel drive. I may put 9mm belts on it as well. And if I do that, then I'm going to go back to the extrusions on this. And when I go back to the extrusions, that means I'm remounting the rails and everything. So in essence, I'm going to take the whole gantry apart and rebuild it. So I will pop those gantry rails off and relubricate them. Why? Your X rails don't get used as often. Your Y and X are used every print guaranteed, right? So most of us are not doing very long, tall prints all the time. So your Z-axis isn't getting a lot of load on it. It's not getting a lot of wear on it, but your X and Y will. So if I do that on this and a couple of other things, which, like, I don't know, I have a clicky clack door set for it. So we'll be updating this a little bit. When we do that, I will take those rails off and re-grease them. The V02 when we, or the V01 that when we did the V02 upgrade, we re-greased all the rails, and it was kind of in need, but it had like over 3,000 hours on it. So when did I last lube the rails on the ender belt? When I built it. And it has very little print time on it. So it shouldn't need any lubricant, Rittenhouse, unless you feel like it's binding somewhere. It should be fine. Like I said, I would take, this is 3-in-1 oil with PTFE in it, a couple of drops of this just on the rail, and then use a paper towel or shop towel and wipe down the rails to clean any dust off of them and put a light coating of oil on it, and that should be fine. But yeah, that's what I do. I use that on my linear rails and my linear rods. And anytime I have to do full up maintenance, like if I'm doing maintenance on the Prusa Mark III or Mark IV and I'm having to take the whole tool head off, I go through and repack the bearings with the Mobile X EPT grease. So, and this is still going. Clipper screen always takes a while. And there is a trick also with the clipper screen. Let me see, creating the virtual environment. keep the, whoop, don't do that. Stop. Okay. So touchscreens are extremely useful, quality of life upgrade for Clipper. Not only do they provide intuitive, convenient controls, blah, 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 hardware setup, the FSC cable orientation, we've got that in the right orientation. I know that because the screen's working already. Software setup. Clipper screen is one of the most popular ways to enable this, blah, blah, blah. We set it up via Kaya. No additional configurations are needed inside of Clipper config files. After setting up Clipper screen, you will find a new clipperscreen.conf file, accessible man-sailor fluid. I haven't needed to make any changes in that file. Rotating the screen, I do know we're going to have to do that. And it says power off, remove it, modify it on a computer where you change the boot config text. You can do that through your SSH. You don't need to do that. So here's the thing that I want to be critical of. So installing Clipper screen policy kit rules. Add user. The user Pi is already a member of NetDev. Adding Pi to group network. Done. Policy kit is detected. Installing the rules. Rules are done. Install network manager for the network panel. We're going to say yes. And if you are not using network manager, you will need to reconnect to the network using Clipper screen or NMTU or NMCLI. That's the thing that always gets me kind of stuck, is I forget that. Now it's asking me for my sudo password or the password to reboot this Pi. We'll put in Raspberry and it'll say, okay, great. It didn't actually reboot, right? But and I don't need anything else. I don't have a webcam on this, so I don't need Crow's Nest to support the web camera. So we're pretty much done here. We're going to do B for back. And you can see that Clipper's installed, Moonraker's installed, Mainsail is installed, and Clipper screen's installed. So we're going to go ahead and do quit. And we're right back here. Now, Clipper screen is up here, right? But it's upside down. So we need to update that boot config, right? Clipper screen's here, but it's upside down, right? This is the top of the printer. This is the bottom of the printer. Clipper screen is upside down. So what I'm going to do is make that change to the boot config file because we can get that from here. So we're going to say sudo, because it's in the boot folder, nano, N-A-N-O, that's our editor, /boot /config.txt. And this comes up and says it's in a different directory. Okay, we'll do Control X to exit, up arrow, and we'll come back here and add firmware into that. So it's sudo nano /boot /firmware /config.txt. And now that comes up, and we need to do some changes here. So we need to find the DT overlay VC4. I'm going to bring this over here so I can read this easier. Oh, crap. Not good. Not good at all. Stop the insanity. Undo that one, because that one really doesn't need to be plugged in. Now stay. Okay. So we're looking for a DT overlay. It would be non-commented right now. Ah, here we go. DT overlay, VC4. It says FKMS-V3D. This does not have the F in the KMS portion. Guess what? Comment it out anyhow. And that's not what I wanted to do. Stop that. Went to DT overlay. Oh, shift. That works better. When you do control #, it does other things. So we comment that line out. And we're going to copy and paste the other two lines all the way at the end of the file. So we're going to go all the way down to the bottom. We want to copy and paste these two lines. So we're going to say, copy these lines, come into here, do a paste. So we can Control X to close this. Yes to save the buffer. Yes to use the same name. Now we're going to do a reboot. Sudo reboot now. And it should reboot. Command not found. Oh, let's try that again. Sudo, S-U-D-O. Always works better when you type things in right. And our system is rebooting. So sorry here, folks. So it's rebooting and we're now in the right orientation. Right, we've got our pretty Raspberry Pis up at the top and everything is in the right orientation. Really high humidity in Helsinki, so have to lubricate time to time. The rust is coming pretty, yeah. And that's why I said it's the same thing as, so I'm going to check this. We did pull an IP address again. But Clipper screen did not come up. So that's interesting. Clipper screen did not come up. And I've had this issue from time to time as well. So what I'm going to do is I'm going to right click here and say restart the session. We're going to log back in as Pi, Raspberry. And we are in, we are good. Now, we're not getting Clipper screen. So there's an issue there. Had that issue from time to time. I am going to check, and Kyber Dragon did come up. So that's good. There is that Clipper screen comp file, or actually, no, let me rephrase that. I'm going to, there we go. So here's where we're at. We don't have a Clipper screen comp file that shows up here. Don't know why. If I add a file, I wonder Is it? We'll create the file. I don't think that's going to matter at all, but we'll see. The other thing that we'll need to do is upload several files. So we're going to click upload, and we want to upload all those files that we downloaded before. So from the stealth burner to the adaptive mesh. We'll get these loaded. We're going to make sure and come through here, and any of them that have the extra little ones in them, we'll just rename and get those out of there so it's just the straight name. And whoops. This particular one, when we rename it, I'm going to actually name it printer.octo/CFG, right? That's the Octoprint config. I want to make sure that I know that. Sure thing, Evil Diesel. Yeah, text me when you get here, because Mrs. Dragon isn't here. I'm still streaming, but that's fine. Text me when you get here, and I'll come down and let you in. That's good. We're still going to have the issue because we don't have a baseline config yet, but that's good. We'll work on Clipper screen here in a second. I'm not sure why, but I always wind up having issues with Clipper screen not wanting to come up, and I don't know why. So it should be a Clipper screen with a capital S. Hey, Maker Viking, how's it going? Welcome on in. So we've got all that stuff there. We still know that it's not going to come up because it's got a nothing for a config. We'll need to fix that. We're coming back over to the LDO documentation, setting up the touchscreen. We kind of ran through that guide as best we could. There's still going to be issues there because Clipper screen's not coming up. We'll see if a couple of reboots will fix it as we go through. The Leviathan board is pre-programmed when you receive it. Okay. Determining the USB ID of, well, hold on. It is pre-configured, but I don't know if it's pre-configured to enable the CAN bus. And we need the CAN bus for what we're going to be doing. So we're going to go through the process and we're going to reflash things. Now, this should be... Yeah, we're just going to go ahead and we've got it mounted. We've got the Raspberry Pi software. There is a potential bug fix that we need to look at. So, we running Bullseye or not? We'll check. We'll just check the UDEV version. It does us nothing to check it. So, boom. UDEV is 252.30. Damn it. I really need this to stop doing that. Oh. You hear me? Stop doing that. Stop being a pain in the tuchus. Okay. So we should be good on the UDEV, so we shouldn't need to do that. Host configuration CAN bus. Configure for CAN only. So we need to run several commands here. This is basically setting up the network interface. We can verify that by doing cat etc network interfaces.d/can0, and it shows the allow hot plug can 0, high face can 0 static, bit rates 1 million, blah, blah, blah. Now, need to restart networking, which might drop our connection in the process. It did not. So that's good. Host configuration for UART interface. Now here's the thing is I believe this is set up for UART using the cable that we're doing. Okay. Yeah, I had the newer Bookworm distro. It may have the button to do that. The issue is that Clipper screen itself is not starting up. So that's an issue. Now I'm sort of confused here. So we've got CAN bus, so the network CAN bus piece config. Now what I want to do is for giggles, not really for giggles, but because I've learned over time, esoterical CAN bus guide. We're just going to roll with this. Blah, blah, blah. This is a new build. Start here. Yeah, exactly. So here's where we do the network interface stuff. We need it basically say allow hot plug can 0, high face can 0, can static, bit rate 1 million, up if config, blah, blah, blah. That's a little bit different. And how can I put this? I trust esoterical a little bit more. Not to say this wouldn't work, but I don't want to take a chance. I've had too many times. I've had too many issues with CAN bus to not follow esoterical stuff. If that makes sense. Okay. So we've got that set. There's some things that need to happen for NetPlan. And this is to make sure that there's permissions appropriate for the firewalls and stuff like that. And basically we're just going through and doing a bunch of copy paste. $120 ohm resistors. We do have the resistor in place. Now for our for the Leviathan, they do have information in here for the LDO Leviathan. Especially there's your 120 ohm resistor jumper. We do have that put in place. DFU mode, we have a boot and then reset. And then here's the catapult config and the USB to CAN bus bridge config. So I think we will have to plug in USB to the Leviathan board and talk to it USB. I don't know. I honestly don't know. I don't know. For now, what I will do is I'm going to unplug this just to make sure that when I'm doing things, I am flashing the right thing. So I'm going to unplug this one maybe, which is to the tool head. There we go. And that'll make it easier because I need to go into the USB on this board. So LDO motors. I've done it. I swear I've done it where I've been connected via UART and done CAN bus, but I can't remember if I did that on the same board or not. So I'm going to plug this into the USB on the Leviathan board. And we'll plug this in to the Raspberry Pi. So now I'm set up to talk over USB. Hey, Western One, how's it going? Thank you so much, sis. Thank you, thank you, thank you. Sorry for the backlighting washout. I swear I think I can do UART over that, but we'll keep playing around. Catapult is recommended bootloader. The USB interface should be used for both USB and CAN for the bootloader. Okay. Getting ready to go work with a horse. Awesome. It is highly recommended to have only the Leviathan connected, which is what I just did. I disconnected the connector going over to our serial port. So that is disconnected, so it's only connected to the Leviathan. We'll need to put this in DFU mode, and where are those? Where's the DFU mode? Right above the arm chip. Okay, right above this UART connector, there's our boot and reset. We need to hold the boot down, press the reset, and then count to 5, and then undo the boot. So okay, so we should be in DFU mode for that now. So if we do an LS USB, we now see a STEM microelectronics device in DFU mode. So that's good. Now it says install clipper. We haven't done catapult yet, so we're going to need to install catapult. We are dang it. Should have Git installed. It should be good to go. We want to download catapult. Knock, knock, you're at the door. All right, folks, give me 1 second. I'm going to put you on mute while I go let Evil Diesel in. Okay, and we're back. You were brave for letting him in? Yeah. No, I got to keep his printing habit going. Okay, so what we do? We did Git is already installed and it's the newest version. So now we're going to install catapult. and create a virtual environment. Oh yeah, he's hooked. The bootloader will be USB as the interface for both USB or CAN bus clipper configurations. So we'll need to CD into Catapult and then make menu config. Once this environment piece thing is done, yeah, that is something new for me as well. I haven't seen that before. First one's free. Yeah, yeah. Um, quite honestly, that's exactly what happened. I gave him a printer. Well, actually, I printed the parts. He, seeing me do all the 3D printing stuff, he decided he was going to build a 3D printer, and he was going to build the Castle Mini. It's a Delta printer. I printed all the parts for him, and he started putting it together. He was running RepRap firmware on a Duet board. I went over, tried to help. He was having problems with consistency issues and stuff. So I went out and got him a printer. Now he's got like 7 of my printers, and it's just, yeah, he's hooked. I've drug him to shows for 2.5 years, so he's hooked. Yeah, I'm the supplier of the good stuff. I keep trying to tell him, before you buy, call me. I've probably got it, and you can get it so you can start printing right now, and then you can backfill the warehouse, meaning the Dragon Den. I've got well over 200 rolls of filament in my house. Probably closer to 3 than 2. Okay, so that command finished. We're going to CD into Catapult, and then we're going to do a make menu config. Okay, and now we need to make things match. So microcontroller architecture, we need STEM32. Processor model is, dang it, seriously. What the hell did I just do? Clicked on something and it went off. Okay, we'll do it this way. STEM 32 F466 or F446. Sorry. Build Catapult deployment application bootloader 32K. Hot crystal 12. USB 32K offset. USB IDs, nothing. Good there. Port bootloader entry, yes. No. Enable status LED says yes. EE1. Okay. There we go. So Q to quit, yes to save, and we're good there. Now we're going to come back over to the LDO documentation, we're going to make. Then we'll get the cam boot. .ben. Be setting it for UART with no CAN bus, so yeah, we're gonna have to do that. Flash catapult. We've got it in DFU mode. We're gonna verify the 0483 DFLL. And run that command. Yeah, that was a new one for me too with that virtual environment. But yeah, I would assume it would be easier for debugging and stuff. You can't get any of your friends hooked. Oh, I took the positron to work and I still need to do it again this week maybe. And I've given printers to a couple of my coworkers. So yeah. So what I'm going to do is do another LSUSB. I wanted to make sure that stem board was still in DFU mode. The ID is 0483DF11, which still matches here. So we're going to copy this. And hit enter. Going through and doing its thing. You're able to get your boss hooked at least. Probably have 7 of them. Got two full car loads of just filament. Yeah. Do the make with the J4. Okay, that's good to know, Bear. Okay, so that's done. Hey, Timor, how's it going? Linux, I applaud your kindness in sharing not just your time, but your gear as well. Yeah. Well, and what it was I was building new stuff and I need to make room. So he's got 3 Prusa Mark 3S Bears, a heavily modified Ender 3, the Flying Bear Reborn 2, my Mars 2 Pro resin printer, I feel like there's something else. You've run previous command, not the right one. What did I do? Oops. I did. Aye. I sure did, didn't I? Well, I wonder if that screwed anything up. Copy. Here we go. Okay. And there we go. File downloaded successfully. So that's good. Hey, Pezliz, how's it going? Big hearts to you. Big hearts. Yeah, a lot of extra space if your friends borrow stuff. Yep, we're good to go. So we did get a flash downloaded successfully, so that's good. We'll do the LS-USB again. And it still shows in DFU mode, so it did not clear. But that's no big deal. I'm going to just hit the reset button and reset it. Or attempt to hit the reset button. And now it shows OpenMoko Inc. Stem 32. So we're good there. So we've got Catapult installed. Had a little nap, getting ready to fix your hot end. Yeah, I'm going to need to do that myself. There's a kid in your wife's family who wants a 3D printer so bad and she is not supported by her parents. You don't want to get her an Ender. Going to try and buy her an A1 Mini. Yeah, that would be better if you get her an A1 Mini. Wait a minute here. Do an LS USB, okay. Oh, and then do a by serial ID. And that gives us our dev serial by ID, blah, blah, blah. So we're going to need this, definitely. I hate when that happens. So we're going to need this information. Come over here. Printer config. So we've got that listed here at least. We're going to save that. I'm not going to do anything more than just save that right now. Get rid of that information. Okay. So now, for USB or UART interface, verify the catapult is flashed successfully. Press the SW1 button on the board. Check the bootloader status LED is blinking. It is. For UART, the USB cable can be removed from the RPi and the Leviathan. Apparently, we're going to need to keep it there. Now I need to do Clipper for the CAN bus. So we need to CD into Clipper and then do a make menu config. So yeah, let's try that again. A little bit harder when you're trying to type up here. Make menu config. Okay. So I have a feeling we're going to be doing something very similar. Come over to this one. We're going to need enable the low-level config option. Microcontroller is going to be a STEM 32. Processor is going to be that 446. Bootloader 32 kilobit. Clock is 12. We're going to do the USB to CAN bus. CAN bus is Papa Bravo 5, Papa Bravo 6. Interface is 1 million. And that's all good. So we're going to do a Q to quit, Y to exit. Switch back over here once we get everything set. And we're going to do our make. You said -J4. / in the path in printer config. All right, I'll verify it. Grandkids are a great place to relocate last year's printers. Yep. Yeah, there you go. I have no idea what it shows up here in my live screen on OBS, but yeah, it's pretty darn small there too. But I do stream in 4K, so if you're at least getting 1080, you should be good. All right, so we're good there. We're going to flash clipper via USB CAN. Configure for USB and CAN. Follow the respective step as indicated. So yep, it does have catapult. Not press this. There. Flashboard with clipper firmware. We're going to build this out slowly. And there it goes, doing its thing. Write complete, three pages, flash success. Verification complete. There's a SHA hash, flash success. We're going to do another ls dev serial by ID type command. And seriously? We're going to play this again. I am going to hit reset again just to reset the board. What's the purging volume multiplier you're using for Turtle and Urkva? Oh yeah, that's true. That is true. Duh. Very true. Thanks, Bear. Oh, great. They're going to be changing the command again. Okay. Blah, 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 blah. And filters, found CAN bus, UUID. The application is Clipper. And yes, I know this is not right. I'm just using it as a placeholder right now. Root letter status ID is off. Sample printer config files for Voron. All right, we're just going to be doing a big paste there. Now, with that being said, the macros, I do not need these. I've got a separate macro set. I always move this over to a separate macro set, so I don't need those. This information will change based on our other file. We're going to start off all the way up here at the top. The serial command, we need to get our CAN bus ID there. Copy that out. We'll put the CAN bus UUID there. Won't need that information. Kinematics. Need to do some copy paste. XY. I'm going to keep, this should be all the right information for the Leviathan board. What I just want to do is verify like the micro steps and stuff are the same. Should be. This should, well, should be the default, so we should be good. Did I change the micro steps on mine at all? I did not. Yes, those should all be good and the same. Uncomment for the 300 build. This is a 300, so we need to uncomment this. Same thing down here. Now, I do want to go over and look at I just had a thought. I have Visual Studio on here. I'm going to bring Visual Studio up and look at that config file side by side. The reason being is I need to be cognizant because I do have some things that are different. Okay, I'm gonna have to sit down for a second. So MCU, virtual ID card, blah, 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 blah. Stepper X. 4032, 400, blah, blah, blah. Five, it's not good. Sense resistor is going to be different because remember our X and Y is now running a 5160 driver and can take a higher power. We're just not providing it a higher power output at the moment. 40, 32, 400. All right, those are good. 300, 300. Homing speed 25.5, true, yep. Again, sys resistor is going to be different because this is also a 5160. These steppers. 40 gear ratio. 8016, 32, good. End stop pin. There we go. So there's the end stop pin for tap. This gets commented out. I'm not sure why that's different, but we'll verify. All right, now I can't see. Position min is -8. This is -5. Homing speed. Okay. Zero 08 110. Turn it. Okay, we need to possibly double check something. So stepper Z. When the old board was connected to motor 2, this is stepper 0. So stepper 0 to stepper 0. Okay. Stepper 0, 1, stepper 2, stepper front left, rear left, Rear right. Front right. Okay. You need to make sure that those were all lined up because otherwise that would be bad. Okay. Extruder is connected to stepper 0, heater, and T0. And this cannot be because it is not connected to stepper 0 because stepper 0 is the other one. And this is on a Nitehawk toolboard, which we haven't installed yet. So this is going to be on the Nitehawk toolboard. So everything related to the extruder needs to be validated. We're going to update the rotation distance. Gear ratio 50-10, 32, 200, 04, 175. Sensor type. Sensor pen, once again, we'll have to update that. And temp 2, max temp 300. Max power full, min extrude 170. We have our PID. And this stuff gets commented out. Zero 046, pressure advance time. Through time, we put that back in. And sorry, I can't see chat, so let me check here. What we got? You're not asking to stir things up. You're asking, saying this just out of curiosity. I know from some projects I have built and from seeing what a lot of 3D printing world runs on, I'm surprised most folks I have seen don't use Linux as their base OSs. Does Bamboo or other popular printers have some Windows-only based software or something? Yeah, I'm going to check that, Bear. I don't have it set up on this printer yet. We'll have to look at how I have it set up on Iron Dragon once I get through this part. And I will come back and figure out what that is. So just remind me as we get closer there. False, E0. Okay, bed heater. Heated bed, blah, blah, blah. Sensor type. 150, 120. Head. All of this gets commented out. Probe. Zero, zero. The offset will get commented out. Speed is 10, sample is 3, median is right, 3, 0, 0, 6, retries 3. Needs to be some activate G code. Fan control. Current cooling fan, that's going to be changed because that's going to be on the board. Heater hot end fan, that will also be on the board. Roller fan. Fan 2. Full V. Exhaust fan. Heater fan, exhaust fan. 10. No tack. Max power 1. Shutdown speed. Kickstart. Heater bed. Temp. Fan speed. Okay. Leviathan. Leviathan. LED control. Output pin case light. And PWM true. I'll leave that the way it is. NeoPixel. This is not connected because it's in the tool head. Homing in gantry. Gantry, timeout, safety home. Quad gantry level. Did uncomment for the 300 build. Seems to be all the same. Speed, move, retries. Do not know why there is two different sections there. That's weird. Also not a bed mesh, so we will copy this. Put it there so we have a bed mesh. Board pins for the EXP. Displays are all commented out. I'm down into the save config stuff. We're going to copy all that. Okay. Here we have all of our PID tune, input shaper, bed mesh defaults, and the Z offset pro. So we're close. We need to validate a couple more things, and the things that we're going to need to validate and do is we still need to install the Nitehawk board. Okay? Yeah, and Otter's Danger Den, I am a Mac guy. I run Mac, so my run a MacBook for both work and personal. I use a PC, a Windows PC for the streaming computer, just because. I've always had. It's actually my gaming rig that I've converted to a streaming computer. Yeah, I do MacBooks. I've got plenty and tons of Raspberry Pis, so I'm familiar with that. I've done Linux in the past. I just kind of support whatever. Oh, that would be nice, Phil Linux. Oh yeah, it is. It is Evil Diesel. Okay, so we've got Leviathan up and running. What we need to do is Nitehawk. Is there a Nitehawk? not there. Leviathan. This is the Leviathan config that we just started with, right? Yep. Let's come over here to Nitehawk-SB. Whipper configs. Nitehawk-SB. File contains pen mappings for the Nitehawk-SB toolboard. To use this config, the firmware should be compiled for the Raspberry Pi 2040. Make sure to include this config at the end of printer config. Overwrite the relevant sections. So I'm going to assume, this might be bad, that the Nitehawk may actually be pre-configured. So all I really need to do is plug it back in. Go back to our putty. What happens if we do an LS USB? Might not find it. Yeah, it might not find it. I might have to actually do a reboot for that board to be found. So what am I thinking of? We need to download this file. We need to upload that file. Oh. Now there's a Nitehawk-SB config. Commercial settings. We need to see, cancel. Now on our printer config, we really do need to do this all the way down here at the bottom. So last line right before we hit the PID tune and stuff like that, the save configs, we'll add the last include. And we need to have it all the way down at the bottom so it overwrites the stuff from the top. The other thing we'll need to do as well is the stealth burner LEDs. We'll have to set that up as well. Catapult and clipper make settings. Why would you? Nobody saw a manual there, did you? Not found. This page does not exist. Well, why not? Still not found. Oh, you're killing me. Oh, okay. Um, what the hell? Is the assumption that the okay. This step will obtain the USB ID of the Leviathan board and the Nitehawk. Sorry. Instead of Voron, it should have been toolboard. Okay. Let me try that. If it's still there, and instead of Voron, we go with toolboard. Yep, still not found. Huh. Yeah, it's not making it there. So if anybody has a full length to the Nitehawk information, that would be great. I mean, I'm assuming that it's good and I may just need to do a reboot. So I am going to do a reboot. And then we'll come back and we'll try and do a by device to see if we can find the device. And I'm sure I don't have the CAN bus UUID in, right? So actually, you know what? Is this the... No, that's a standard board. Hmm. Damn it. Like, why is it still not coming up? Because we changed the... orange red one. Whoops. Those two aren't installed. Probe points in resonance tester. You know what? I bet you that's in here. Ah. That's good because that means it's talking to things. Second homing speed in Z. Unable to parse second homing speed. Is that a deprecated? No, because that was a manual update where I just added 10 and Mark did a comment for default. Oh. Did a comment without a comment marker. So fun times here. Restart method is not valid in section MCU. That's helpful. Restart method is command. Nitehawk. Restart method is command. Pretty sure restart method is is that not required for CAN bus? Not required for CAN bus. Okay. Okay, this is good because this means it's at least talking to the main controller, the Leviathan, and it's having an issue trying to talk to the Nitehawk. So that's good that it's taking that time. Okay. Now, where are we at? Darn it. Oh, no. Needed, but not necessarily. All right, there would be the make settings if we need to do the make. Back to that, we don't need that. Okay, here. Huh, never done that before. Mainsail. I don't think I've ever done that before. Printer, devices. Well, I'll be damned. I never knew you could do that. Clipper. Oh, interesting. So USB does find that, but it's not finding the Nitehawk. So it looks like the Nitehawk board is not configured. So we're gonna have to do some stuff to get the Nitehawk board configured. Good. Did we get rid of esoterical yet? No, no, not. We have that stuff. We've got catapult installed. Need to do a make menu config. And use this for the catapult. Okay. So we're going to change this to Raspberry Pi 2040, SlamDiv 2, do not build. Pretty much just, whoops. Port bootloader, enable pins. Bang. GPIO8. You to quit. Yes. We're going to do a make clean because we need to clear out anything from the last one. And I have a feeling we're going to need to open up our tool head board and click on some buttons to put it into like a DFU mode or something. Probably the same thing we did to the Leviathan. How do we put this in DFU mode? Boot 0 resets. So boots towards the front, resets in the back. So we got to hold down boot, click reset, hold down boot, boot, boot. So we should hopefully have that in DFU mode now. Use flashing steps. Let's run LSUSB. And I am not seeing it. It's plugged in. Got power. There's power up to the board because I'm seeing pretty lights. Do I need to remove power and hold the boot down to boot it? Ah. I mean, I've got the ACT light on, ACT lights on. All right, so here's what I'm going to do. I'm going to unconnect it. Do an LSUSB. It's all the same. Okay. Ah. I don't think it was all the way in on the Nitehawk board. I now see an RP2 in boot. So we're got the boot. Note the address. You can then flash catapult to your tool head by running a make flash device equals builds the ELF UF2. Trying to send it. Hope I didn't lose everybody going through all this. I know this is maybe not a rousing thing doing all this, but found the device, resetting the interface, looking, exiting, framing, flashing, rebooting. And I am getting a flashing acolyte, so it did flash with catapult. Just setting up VPNs for clients. Oh, that's fun, Rittenhouse. Awesome. Playing with the doggo. Well, that, you need to do that. Yeah, do that. Click here for the next steps. Catapult is now installed. Shut down your Pi. Power off your entire printer. Plug that stuff in. We're not doing that because not doing that. Now what we need to do come back to the Nitehawk, go to images, and let's look at Clipper make set. That's going to look pretty stellar as well. So now I think we're going to CD over to Clipper. Make menu config. And are the, yep, enable extra low level. We're going to go down to Raspberry Pi 2040. No bootloader. Right, no bootloader offset. Or no, 16 kilobit bootloader offset. COM interface. Yes, USB serial. USB IDs is left. And GPIO pin, once again, is going to be bang. GPIO 8. Okay. Need to quit. Yes. Make clean. J4. Oh, you're setting up Meraki VPN servers. Nice, I guess. Oh yeah, dear God, Rittenhouse, yes. Okay, now so I think we should be able to do the make flash device, the same command, just as long as we're in the Clipper folder. Does that sound right or not? Really, really great if they had documentation on this. So it took a compile error because it does not know GPIO8. Ooh. Let's fix that. We'll fix that. That was a syntax error. Oh yeah, yeah. Well, I guess what we could do is run this command and see if it shows up. If it does, then we'll continue. If not, then something else is weird. Oh yeah, that's all given there, Rittenhouse. That is a given. They always do that. Drives me crazy. Okay, we got a clean make, so that's good. I want to see if anything shows up can ID. And it doesn't. So there's nothing there. What if we do an LSUSB? So we have an ID for the RPI 2040, and it's a different ID than what we had before. So what if we are in the clipper? So what if we do a make flash device, grab that device ID, all right. So I guess we got to put it back in bootloader mode. Now it comes back into the older bootloader. There we go, make flash QE8A0003. It seemed to flash. Got a device ID. So now we need to do the serial device ID, blah, blah, blah. Hey, look at that. But that says USB catapult. It shouldn't be catapult though, because we just tried to redo it. I know why, because we set it with a bootloader offset, so it still sees catapult, but so it doesn't pick it up there because it's not. Ooh, what is it? Okay, yeah, double press is not getting me anywhere. That's probably not going to get me anywhere because we're in DFU mode. So LSUSB will show me this in boot mode. Should we just be putting it in, just do it straight clipper? Like it doesn't make sense why. We get 16 kilobits for a bootloader. All right, maybe I did something wrong there. So let me come back up here. We are back in boot mode. So let's go to CD catapult. Right? No. Make menu configs. So we've got 2040 W25Q080 with clock division 2. Build catapult deployment. Do not build. USB. Or bootloader entry on rapid double click of reset button. That's what I was doing. Rapid double click of reset button. It's not going to find it on that though because it's okay. So we have it there. What if we do the CD flipper? Failed to flash, unable to find TTY device. Device is already in bootloader mode. It can be flashed with the following command. there. Then boot mode. QE8A:0003. Make flash device. Okay, rebooting device. Device should be there now. In an RPi 2040. Okay. It says catapult. I'm just going to copy that and I don't know. We'll try. That shows a USB clipper. And these two I need to comment out. Zero 0.5. Fans. No tack, no tack. Running fan, no tack, no tack. Sorry for the desk scroll there, everybody. All right, have a good one, Rittenhouse. Okay, good. And it'll overwrite the pins, so that's good. I'm just trying to make sure I'm good here on my thought process. XYN stop, we're using the ones on the Leviathan board. We're going to reuse that GPIO 13 as a filament runout sensor. Probe, all that we need to do is change the pin, which is what it's going to do, is change the pin. Stealth burner headlights. That'll be good. So I need to turn this piece on. Actually, this copy this. This gets commented out. Because on the stealth burner, we have to identify the pin here. And everything else gets picked up through here because it provides the macros that change the color for various things. Now, I'm still kind of confused on the Nitehawk. So we're in Clipper. I'm going to do the make menu config. Now, if I get rid of the bootloader, that doesn't make any sense. Says to use USB. This is USB to serial. We're not doing UART on this board. We're not doing CAN bus. We're not USB to CAN bridge. Why the hell is this thing not flashing to Clipper? All right, so as a RPI 2040, It should not be, well, going to Clipper Bend. I'm confused. I'm confused. I'm confused. And I think I just, well, that's the problem. There's no documentation, right? It shows me catapult configs. It shows me Clipper configs. We're setting this up for USB. I don't know why we would use catapult except for it's a bootloader, right? We're not connected via CAN bus. So it's not going to find it on the CAN bus. The only CAN bus on here is the actual Leviathan board, and we're going to have a pigtail that comes out so that we can put the whatchamacallit, the box turtle on it. 120 ohm resistor, there's a 120 ohm resistor right here. But what I'm saying is we're connecting over USB. There is no CAN bus here. The Nitehawk is a USB board, not CAN bus. And it just makes me mad that because see, it's showing this as USB Clipper, and now I'm like, how the hell do I get Clipper on here? Firmware Clipper configs. There's the stealth burner config, taco macros. It has a comment here that says go here on how to do firmware setup and update, but this link doesn't work. So we go here, still not found. Okay. Full board. Uh-oh. Well, I'll be damned. Maybe we made some progress. Damn, seriously? Electrical specs, firmware setup and update. Catapult and Clipper. Catapult is bootloader designed specifically for Clipper. Awesome. So it would have been installed. So I've caused this pain on myself. Awesome. Oh, is that what it is? Run this. And we get the catapult. Okay. Let's install a couple of things. I'm pretty sure this stuff's already installed. But I wonder if that's the issue, is I've got to actually stop the Clipper service. So they're using Catapult as the bootloader. That's it. So in order for you to install Clipper on a board, it has to have a bootloader. Remember, that's the issue with some of the older Creality boards and stuff, is there was no bootloader, so you had to use an Arduino or some other tool to basically use as a bootloader to install and write the firmware. So they're using Catapult as the bootloader, which would allow you to go into boot mode. So I think the issue here is I need to stop the Clipper service and then do the flash. Okay, so we're in Clipper, yes. I'm going to do the LS-USB again, just so it's close by. I'm going to do stop Clipper, make flash underscore device equals /dev /serial /by -id /make space flash underscore device equals dev serial by ID. Oy. Okay, so those you were asking, you did not go deaf. I just my mic died. I'm plugging it into external batteries, so hey, Cap Bowden Tubes, is that Aaron? Awesome. How's the little one doing? Um, yeah, so they're using Catapult as the um bootloader. So you basically get into boot mode with Catapult, um and then you can run your Clipper stuff. Or yeah, you can install your Clipper. But my question is, not really a question. Um, so we've got CAN bus. CAN bus is looking and can't find things. Got that there. So flashing an RPi 2020. Confirm it's in boot mode. Run an LSUSB command and see if the device is in boot device or similar. Okay. Then run Catapult firmware in your board. We've got Catapult on there. Power off everything. Take out any DFU jumpers on your tool head. And it's not going to be on the CAN network because it's not connected to CAN. So how in the hell? Uploading Clipper via Catapult. Okay, in this section, we can use an alternative method to upload Clipper firmware using the bootloader. What is missing? Catapult's there. Okay, so let's go through and do this. We're going to set up our Python environment and let that get set up again. Creates a Python 3 environment and Catapult env and installs the module PySerial, blah, blah, blah. Now we must force Nitehawk to enter the Catapult bootloader and obtain a USB serial address. Start by quickly double-clicking the reset button and you should see the ACK light blinking slowly. Well, the ACK light is blinking slowly, so that should still be good. Run your ls dev serial by serial ID. Shows up with USB catapult, yes. Okay, give me 1 second, folks. Actually, folks, give me just a second. I think we're there, but I need to go downstairs real fast and help Mrs. Dragon. So I'm going to put this on mute for just a minute, and I will be right back. Okay? So I'll be right back. Okay, we are refueling. So Aaron, funny that you mentioned this. This machine is going to get the orange cap tube. And in fact, so on the rear plate on this one, I had installed a piece that brings the PTFE tube out at an angle because the spool holder is normally on this side. Well, with putting a box turtle on the top, the PTFE tube's coming straight from the top and back around. So I'm going to reprint this piece, and with one like I did on Iron Dragon and the Trident 350, that will allow me to come straight out the back and that'll give me a better PTFE tube alignment. But the orange one's going to go on this printer because this printer is orange, black, and purple. So it makes good sense to put orange cap tube on here. And yes, Mama Bear brought me a refill. You have a hurting extruder on which printer, Pezliz? Yeah, so Bear Claws, that would have been the one way to do it as well. Had I gotten to this page and read through it, I would have realized that it says the board is pre-flashed. So yeah, I may have caused myself this, right? So what we've got now is we're going to put in this command, and this is going to allow us to use catapult. Ooh, actually, let me not put in that command. What I want to do first is cd into Clipper. Now I'm in the Clipper directory. I am going to put in this command, and this command is calling the catapult environment that we just set up with Python, running the catapult flash tool with the dev serial by ID. So we're telling it to put it to this destination. And yeah, at this point, the reason I wanted to make sure I was in Clipper was to make sure that it was pulling the Clipper output file. So we'll see if this goes through. And hey, that looks like it just flashed. That looks like it just flashed. Now we're going to up arrow back to our ls dev serial by ID, and we now have it with Clipper. Woo! And we're on the latest, greatest version of Clipper, which is the one that we're running on this machine. So we'll copy that. We'll come over to our main sail. We need to go into the Nitehawk-SB, right? MCU Nitehawk. We've got the serial here. We will paste over that. The other thing that I want to do real fast is on Iron Dragon. I want to see if I set up the filament cutter information on this or if it's in the AFC stuff. Okay, so I'm not seeing the filament sensor in the main, which means the filament sensor in the tool head must get set over here in the AFC stuff. Yeah, filament switch sensor tool is where that will get configured. So we'll need to remember that. So for now, let's do a save and restart and see if this comes up. At this point, I just want it to say, I've got everything, come up. Because it shouldn't care that there is nothing connected to the CAN bus other than the board, right? Hey, Petty Ruxpin. Hey, Petty, by the way, yeah, package can't go out today because it's a federal holiday, so post office is closed. Printer not ready, dang it. I just realized something. It complained about MCU before. May still complain about MCU this time. We've got two MCUs defined. We've got the Nitehawk one, which we just fixed. It's now /dev/serial/by-id/USB clipper, blah, blah, blah. So that's there, and that's MCU NHK. And the other MCU, once the underlying issue is corrected, blah, blah, blah. So the only other one is under here, which is the CAN bus UUID for the board itself. Right? So checking for catapult nodes. No catapult nodes, which is okay because this is not going to be in catapult. What we got to do? Mainboard flashing. Installing US Cambridge Clipper. So I'm wondering if something is now up with the CAN bus. Up mode default, Q-Link 1024, bit rate's 1 million. So it's not finding the MCU. Not finding the Leviathan board. We're connected to it via USB, and we've got the cam bridge set up on it. LSUSB finds the board as a CAN adapter. What am I missing here? Did we break something? Well, let's just go back and give it another shot. Okay, so catapult, make menu config. Leviathan board. Microcontrollers, M32, F446, 32 kilobit bootloader, crystal, 12 megahertz, communication on USB, offset 32, bootloader, enable status LED, EE1. Clean. Um, J4. Ay, 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 ay. 1 step forward, 2 steps back. M32 board. We've got to put the board in DFU mode. Get that completed. We need to put our board in DFU mode. All right. Let me LSUSB. In DFU mode. Yay. We're in catapult. Did the make. Now we need to copy that. Paste that. And it did that. Go in DFU mode. Nope. Listed as a CAN bus adapter now. Okay. Catapult is now installed. Take a look at this. The RPI 2040, we're not seeing this. So you just do a reset on this. Okay. Double click the reset button. All right, there we go. One in catapult, one in clipper. Need to change over to clipper. Make menu config. USB to CAN config. So enable low level. Go back up to STEM 32. F446. 32 kilobit bootloader. Clock reference is 12. We're going to do the USB to CAN bridge. CAN bus on PB5, PB6. 1 million. Get rid of that. We'll make clean. Do a We'll make of that. This is always the fun part of software, and we haven't even gotten done yet. Once we're done with this, then we need to actually physically go in and install the CAN bus pigtail in the printer and set up the box turtle still. Which I've been told that board is pre-flash, so we shouldn't have to flash the AFC light board. Fingers crossed. Okay, so we got clipper done. We're going to stop the clipper service. We're going to do our LS dev service to make sure it's still there. It's still there. We're going to grab a command. And we're going to flash that board. God, I'm going to lose my crap. Lose it. I'm going to lose it because it won't let me. It's telling me to do Python 3 serial. And I'll probably try and do this and it'll tell me no because it's already installed or something like that. Nope, it's doing it. Okay. Okay. Now that's installed. Let's try doing the Python 3 again. There we go. Away we go. It went. Flash has success or is successful. Now we're going to do LSUSB again. And we now see our OpenMoko RPi 2040 and OpenMoko CAN adapter, which is what we were looking for. Check that our CAN is up and running. We have a queue length, we have a bit rate. So that is up and running. You now run the Clipper CAN bus query to get the CAN bus UUID of the main board. So we've got a UUID. Back up here, CAN bus UUID. Hey, look, it's the same. You flash or restart the Clipper service. We've got lights. Holy crap, we did it. We did it. See? We got light. The lights are on. That means we're good. Whew. Goodness gracious, that was painful. Okay. It helps clear the bed before you start another print. Exactly, Chewy. Exactly. Okay, so I think we're good. I'm going to leave this octo config here in case I need to go back and look at anything. Apparently I need to, I've developed a drinking problem because I just tried to pour coffee out the side of my mouth. Okay. Whew. I'm still having an issue with Clipper screen. I have a system package that can be upgraded. Like I said, I'm still having an issue with Clipper screen not coming up. I think we're done with those two things for now. Yeah, the lights are pretty strong. Close that, come here to the dashboard and case light. Whew. All right. Part fan's working. I've got lights on the stealth burner, so that's good. I need to button up the. We need to button up the stealth burner. All right, stealth burner is buttoned up. A couple of other things that we're going to do real fast. I like to do it over here. We're in stop. Okay, X and probe is triggered. Gotcha. Y and stop triggered. X and stop triggered. Y open. Okay, my CAN bus is not working. A little disconcerting. Tad bit disconcerting. Because I verified the pinouts of the boards were the same. This is a Nitehawk board. Ground, GPIO, power. Inductive probe, ground, signal, power. So that is the same connection. Hey, Miss Lee Marie. Well, yeah, my problem is I just kind of get lost in it. Power, signal, ground. Okay, I am seeing the light change on the backside of the CNC tap. Excuse me. So that's working. So this tells me it's probably something in the config. So Nitehawk-SB, it just changes the probe to GPIO 10. Okay. That sets the right probe 10. I was going to say I'm going to desk scroll, but I don't have the screen up. So it calls out the probe, but that's going to get overwritten. Yeah, I know, Lee Marie. This front camera. So if I go to the main view, so that's that bottom camera. it keeps freezing, and I don't know why. It's a driver issue, and every time my computer does updates, it's hit or miss whether this actually works or not. It drives me insane. What's even worse is this camera right here is the same exact camera as the main camera. This one hasn't had any issues. It's that one that keeps having issues. So I have no idea why that one camera keeps crapping out, other than I've been told it's the Intel driver chips in them. So what I'm trying to look at here is the probes. EG15, faucet off, faucet, speed, samples, results, distance. Oh, you know what? I wonder. Pull up PF1. No pull up on the Octopus. It does show a pull up if you're connecting into the board on the Leviathan. We're overwriting the probe pin with the Nitehawk, and the Nitehawk probe is not showing a pull-up. So do we need a pull-up here for this to work? I don't know. So we'll find out. Hey, there's some lights again. Whew. So it's triggered. No, so it wasn't pull up. What the hell? It is GPIO 10. We got to fix that case light. Case light. Oh, there. Case light. Startup value 020. Shutdown value 0. Value 1. Actually, gonna solve that problem, I think. Lot better. Lot better. Okay. Why is my current issues with upgrade to Nitehawk? My CNC tap is in a constant triggered state. All right, so let's see if Reddit has a solution for us. Mainboard drivers, yeah, and it could be because I believe I'm plugging them into different USB, um, like lanes or whatever on the board. So I'll double check. Yeah. Yep. So we'll have to figure that out. Okay. Not printer. Nitehawk. Probe. Hilda Bang. Let's see if that fixes it. Uh-oh, we're open. Well, that didn't fix the problem. It changed the problem. Dang it, stop going in there. So the bang changes from triggered to not triggered. Now it's triggered. All right. Okay. So yeah, something is up. I know there was a weird difference, but it's I didn't change anything on the cable. And I've looked at the pinout for the LDO, like standard tool head board, and the LDO Nitehawk-SB board, and they are 100% the same, right? So with it being the same, sorry, unless there is, yeah, 24 volt ground ABL right in the middle, right? The same exact pinout configuration for this one. I don't know why. Oh, well, that's going to be a bad thing. Well, no, it shouldn't be. Maybe, maybe not. So here's one thing that I didn't check. That says probe VN. Can you see that power reading? This one has been configured for 5 volts. The Nitehawk is configured for 24 volts. Now, yeah, I was getting a light change. Getting to be a very iffy light change. So yeah, the wiring is in the right place. The part that's not is the fact that I just put 24 volt through potentially, oh no. I'm gonna have to set this up and take a look at it. I cannot remember which version of the CNC tap is in here and whether or not we may have just fried that board. I mean, wouldn't be the first time. Most likely won't be the last. Before we do that though, this goes back here. Let's mount our pigtail here for our CAN bus. So your female adapter with the male pins goes into your keystone jack with the screw hole on the back side. So we're going to push it through in this manner because that screw hole is going to be used to hold the plug in place. Give me 1 second. So may not be happy with me, but we'll hold out that it's not completely mad with me either. So we're going to push this in until it's basically flush with the back there. We'll put an M3 screw button head in the back. Doesn't have to be huge. We'll grab like an M3x6 button head. What this is going to do is keep it from being pushed back out whenever we're plugging in the connector. So and this is just getting threaded directly into the plastic. Just like that, to keep that connector in there. And I want this where the latch is going to be at the top. Come on. There we go. That side's in there. This side comes in here. And we'll make this latch in there somehow. Oh, so pretty. I think we're done, but I don't want to like fully close this up just yet. Famous last words. Okay. Probably going to be the easiest way. Really? I'm going to try and see if it's a... If it didn't smoke, it's probably fine. Well, yeah, it didn't smoke, and I was still getting a light. I just know that some of these are 24 volt tolerant and some are not. And of course, the PCB is screwed in from the bottom up to the top. So, you know, you pretty much have to take the whole darn thing off in order to check that PCB. And I really don't want to. I mean, yeah. I don't know if it was just like didn't like being upside down because the wires appear to be good. Though I will say it would not be the first time that I've had. I'm bringing it around here. I wonder if I can just bring it this way and figure out a nicer way of tucking it. It would not be the first time that I've had a wire that needed to be um, recrimped. So it shows it's triggered. If I lift it up, the light changes and I'm still triggered. So okay. Put wires on top. I mean, other than trying to check and make sure that there isn't a broken wire in here or some type of damaged wire in here, I'm not sure what else I can do. So let's check that real fast because that'll be relatively easy to do. Okay. So we're going to go into continuity mode. Black wire. Come on now. Black wire to black wire. Believe it or not, this is kind of a pain in the butt to do. Black wire to black wire checks. Yellow to yellow checks out. Red to red checks out, all at 0.3 ohms. So the wire's good. Now I need to verify my manual. CNC tap build guide, come on. It could very well be that the signal and ground are swapped or something like that and just need to be changed. So don't want recent, no starred, your computer, download. Okay, sensor side, board side. So it's supposed to be yellow, black, red. Board side. Yellow, black, red. Okay, so 5-volt ground and signal. Okay, so I have pinned this appropriately for the connectors that I've got. Question. CNC tap. Oh, I think there is an update. That's what I'm trying to look for right now. Come with 2 different wiring styles. signal, ground, 5 or 24 volt. Goes over to signal ground 24 volt. And I remember that part is the colors of the wires kind of got you. CNC Voron tap contain or operates on a low voltage trigger. It does not trigger on high level. When using the CNC Voron tap with the EBB-SB 2209 and RPI 2040, connect it to the 5-pin port following the wiring diagram provided. Signal wire of the CNC Voron tap should be connected to the servo's signal wire. The firmware should be set to pull down the signal pin to prevent the detection failure of the trigger signal due to signal wire breaking. Operates on a low voltage trigger. Okay, so wire the signal output from the tap to the servo pin on the probe port of the EBB or motherboard. Trigger the servo pin to be pulled down in software. We're not doing that. We're not going to a servo pin because we don't have it. All we have is that one cable to go to, unless we run a wire home run all the way back, which I'm not going to do either. And will most likely have a pull up resistor implemented in hardware, which means that the internal pull down resistor will not work. Figure the pin to be internally pulled up when the probe is stowed, and it will be pulled high by the internal probe circuit, the internal MCU pull up. Okay, so it sounds like it needs to be pulled high. Hey, Bexy Beans, how's it going? I think I do got this. It's just a pain in the butt. And no, I don't think it was a Magic Smoke event, Two Wolf, because I'm still getting a light on the board. So if I bring it around this way, I don't know what I'm going to do with this cable because it's not going to stay like that unless I zip tie it. Well, I'm staying hydrated with coffee. I mean, that doesn't dehydrate you, does it? Keep going until I bust the thermistor wire here, and it's really going to be it. Okay. Plugged in, power on. Okay. So I'm going to bring you guys around in here. Sounds like we need to pull it up. Right now, it's just trying to figure out what we have to do to get it to trigger itself and reliably. Because what I can do is pull you in here, and you can see that light there, right? That's the probe light there. Lift it up, it goes to a different color, different brightness. Okay? But what we're not getting is an actual indication or difference of indication. Like right now, it says it is triggered. If I lift it up, I know it's not triggered. It still says it's triggered. So something's there not working. So if I go into the Nitehawk board, and I do the up caret, right? Because the caret symbol is the pull up resistor. So we do the caret, which is the pull up resistor. So that should have pulled everything high. Okay. And I am getting the lighter colors and stuff. That's good. It's going to be so fun. Like, so fun. Okay. So we instituted the pull up resistor. Right now it still says that it's triggered. And if I lift it up, it still says it's triggered. So what is the magic here, guys? That doesn't seem to fix the, or solve the problem. Just for giggles, we're going to look at the printer config. Probe section, XYZ, speed, samples. Yeah, nothing there. It does have a pin defined, and it was as a pull-up. On the old LDO board. On the new LDO board, we've now got the pin defined because once again, it's keeping all the other settings, and this is called at the very, this file right here we're looking at is called right at the very end, which overwrites the pin config. I've got this set as a pull-up, and we're still not getting a difference in trigger. If I add the bang, I should get the exact opposite. I should be constantly open regardless of what position it's in. Yep, we're open. Open. Yeah, so I either get always open or always closed, but something's not working right. Hey Zombie, how's it going? Hey Zombie, have you installed the Nitehawk board at all on anything? The Nitehawk stealth burner? So my issue is I can't get the tap, the CNC tap to work. It's either always triggered or never triggered. And I've got it set for pull up. I get rid of that and just go to nothing. I believe it's the 524. So the old sensor, or on the old board, I had it configured to 5 volt. Don't ask me why I triggered it to 5 volt. I have no idea. This is an LDO Rev C kit with a CNC tap. I'm going to have to take, I was trying to get around having to take the tool head off, but it looks like I'm going to have to take the tool head off. I don't know if it's a version 1 or a version 2 of the CNC tap. That's the problem. I mean, the light's still there. The light is triggering. I'm not getting it to trigger in the software. Red to blue, no. It does not switch from red to blue. I'd have to plug it back in to show you it. I mean, it does change intensity, but it does not change. Well, it was working on the generic LDO toolhead board. And the only difference is we've now installed the Nitehawk board. like I said, the old LDO board, I had changed it from 24 to 5 volt. I don't know. Like, no magic smoke has come out, but that doesn't necessarily mean anything. Kind of sucks that I'm going to have to pop this thing off. Because there's no real easy way to get to the actual sensor to look at the sensor itself to see which version I have. So, I guess tool head's coming apart again. Well, and I've looked at the. So let me go back and rephrase that. The pinout, the working config that came off the LDO board, or excuse me, the standard LDO toolhead board with the 14 pin connector, that it's pinned in the same exact way, and the pinouts between the two boards are the same. Unless there is something wrong in the LDO Nitehawk documentation, and the pinout is different, I don't know. What the hell am I looking for? Little LDO screwdriver, where did you go? But yeah, that's kind of where I'm at. I'm getting stumped. The pinout and the orientation of the board's the same, and if it was different, then I would have fried it because it would have swapped the ground and voltage, which would have fried the board. And since it did not fry the board, I'm assuming that that is good. Bum, 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 bum. And so far, everything else was working except for, the sensor that I need to work. And I did continuity on the wires for the sensor, and those are all good. So that part is good. Take this out, that out. To be able to take this off. Sit there, stay there. So signal is yellow, ground is black, voltage is red. I cannot see which Like, I can't tell if this is 524. Not. And take these 4 screws off. And I should be able to pop this off of the rail. I'm using the 3-pin probe port on the Nitehawk. I may have to run the signal over to the Y end stop, which would really, really suck. Rev 1, 5 volt. So I put 24 volt in it. Damn. I don't know if there's a 5 volt rail on the there's not a 5 volt rail on that, is it? Probably killed it. Yeah. Good possibility of it, eh? Damn it. Question is do I have a spare CNC tap? There is a possibility I might. I don't know. $22.09, $22.40, bars. Oh look, more stealth burner printed parts. The frustration is high. I have most likely toasted it. It doesn't look fried, but I'd be careful not to damage the Nitehawk board. Well, if anything, I would have put too much power into the tap. So the Nitehawk board's fine. Question is like I said, do I have another CNC tap that's a newer version on hand, or if I'm going to have to go find one elsewhere? Bondtech, shooters. Oh man. Does not look like I have one readily at hand without ripping it off something else. Um, right, thanks. Yeah, is that okay? There is 5 volts, so I should be able to pull 5 volt in GPIO. Provided this board has not toasted already, I should be able to potentially depin this and try it out, right? At this point, it can't hurt, right? Pull the 5 volt and the signal out. Move those to a separate, or move those into the other header. 5 volt signal, ground. Um, I mean, at this point, we can't do anything worse to this particular sensor. So either it continues to work or it doesn't. If it doesn't, then I need to get the 5 and 24 volt compliant version. And I'll have to try and get that like as quickly shipped as possible. Don't know what that'll be like. Bum, 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 bum. Okay, so I'm going to put this back on. See about getting this lined up. Okay, so that's there. We'll leave this coming out the back. We'll flip this back over. set it on there and get this part screwed back on there. So if anything, this is going to be a good marathon stream to show people that every single time you go to mod something, there's always something new to figure out and to help get things moving, right? Always something new. Okay. So ground is at the top, so we'll take our ground cable, put it in the topmost pin there, and go at the top. Other two need to go into the X cable here, XY. We're currently using a ground and the X. So we'll need connector out is what we need. The connector. Here we go. So we're going to try and put signal in the Y. Power in the 5-volt. How much easier to work on when the frame's exposed. I'm not going to do all the screws. I'm just going to do the two here and see if we can get that figured out. And if this works, we'll come back and do the 2 long screws. Okay. We're going to have to change some pins. We went to the GPIO 12 instead of 10 for that probe. So good thing is I am seeing, the light still, which is good. Well, yeah, and that's the thing. I didn't even check. I knew that there were older, and I have a mix of old and new. So I don't need to get the whole thing. I just need to get the sensor board. So I'll buy several of the sensors. Lights are on. Nitehawk probe. We're going to change to, we're going to copy this. 12. Default is GPIO 10. Save and restart. Should be a lot faster. So it's currently open. I lift it up. Triggered. We're still good. Except how is this normally? Is it? Yeah, down is good. Up is going to be triggered, just like this being open is good until it hits the end stop and then it triggers it, right? Yeah, that's the expected behavior. Here we're good. We're printing. Go up. Triggers. Okay. We've got chamber temp, the Leviathan board, the Nitehawk temp, and the Raspberry Pi temp. Extruder, if I start heating that up, the hot end fan came on and it's heating up, which is good. Turn it off, and once it drops back down to 50, it should shut off, and that will be a good. Now, since I have put 24 volt to that sensor, I will order a couple of new ones because I may have just really altered the lifespan of that sensor. Okay, and we've gone under 50 in the hot end fan shut off. We had checked the part cooling fan earlier. Yep, that's working wonders. Case slide at 20. Case slide off. Both burner lights are on, so that's good. What else do we need to check? Home X. Okay, that's bad. Oh, duh. Because I took a part off thinking, oh, I don't need that part. Yes, I do. I don't know, the actual part that triggers the end stop. Oh, there it is. Good. Well, that's good and bad. Good in the sense that things are working, bad in the sense that I broke what was working. And now I have to take, I don't know, I might have to take tool head partially apart. We'll see. It would be great if I didn't have. Sensors are wear items anyhow. True. Very true. Okay. Spin this back around. Pull this over. Now the good news is I just need to take the fan shroud off and drop the hot end itself. Not like drop it, of course. But fan shroud off. Should be able to move that out of the way. And put these back in. With the same size or the same size? Like, I don't see why that plastic part's there. Let me take it off. Whoops, now I know why the plastic part's there. You put it back on. So Chewy, how's the 2.4 running? Hopefully it's still doing good for you. You're actually sitting in front of it right now, printing Filomatrix parts as we speak. Good. Good. So this is the old Bowden tube. I'm going to check and see how long this is. I'm going to do that down here on the ground, but I'm going to check and see how long it is. If it's under a meter, then I will replace it with a full meter. And it is going to be under a meter. So that's good. I'm going to replace it with a full meter of the Capricorn reverse Bowden tube because it's orange. And I have an ulterior motive with doing it at a full meter. And that is, I now know how long it is. So by knowing how long the Bowden tube is, it makes it easier for me to set the distance for the box turtle in the config when we get there. In the bag, please. Don't fight me. Get in the bag. Oh. Okay. So that part goes there. The top will sit up here. And wow. Let me see if I can't get some of the dust off of this. Works a little bit. So we've got that. We've got our box turtle. And one of the things we need to do with the box turtle before we can do much of anything else, we need to get our ends put on. Now, this one I did closer. This one I didn't. I've got strain relief here, but I left it with some room because this is the part that goes into the box turtle and into our AFC. So we'll need to feed this through, and I'll need to get this plugged into the AFC. And I may have to undo the one extruder, or at least part of it, to rotate it around. It's tight fit. I could probably move the AFC light board down just a bit, which might also give me a little bit more access room. To the wire or the connector. So I move that down. Hear me curse, I apologize. So the 4-pin connector on the AFC light board is in such a way that the locking latch faces down. And with the lane pieces the way they are, I am literally running into the point where I can't latch the clip because as it opens up, it runs out of room. So I'm going to have to lift the board slightly, plug in the locking latch clip, and then remount the AFC board. Not hard, just annoying. But, okay, so that's now latched down. Yay, yay, the gang's all here. We'll put that PTFE2 back in. And I'm going to want to add it to the zip ties in here so I have some strain relief. So we will unclip that zip and we'll snip this zip tie. Just add a new one there and make sure that we connect in our box turtle CAN bus cable. Box turtle parts after that, rock on. So I believe I have stated so, but for those of you that might not have been here, I am getting an LDO box turtle kit, which will be nice because I've done a few box turtles, but having an LDO kit will be really nice to compare and contrast it against all the self-source ones I've done. So that will be nice. So we will have one of those coming. I don't know if the LDO kits, if somebody already out there has one, I don't know if they come with the bottom plate. But what I've done is I've 3D printed on the rat rig some bottom plates here. Those will go right underneath there like that. So I'm going to take the I'm going to take the feet off. Take the corner pieces, take the feet off, and get these in there. Corner pieces off. We need to take the feet off. At least I'm going to have to take one off. I have to take both off. I've never put the bottom plate on, so I'm not 100% sure how it goes on. Be feeling our way around this. Apparently it's going to go on just like that. Apparently I dropped an M5 nut and didn't feel where it went. There we go. Okay, so the plates actually go right up in the corner there, and then you'll come down with the, so this is kind of getting pushed out some because of the wiring, but you'll have your M5 nut in the slot there. You'll bring your foot in. I have to need like 8 hands, but I'm trying not to Darn it. Trying not to do that. So normally you would have all four, or you would have a plate that goes all four corners. I don't have that on this particular build because I didn't feel like cutting it. So this is just a printed plate that I cut in half. In the slicer and then sliced. So, come on you. You there, you there. Yay, verily, let's go. There's going to be pressure from compressing the feet that's going to hold it in place. There we go. And then on the in the middle, what I'll do is I'll print off a couple of the Voron clips and use that to support the middle seam. So that is my plan. So as you can see, it's getting pushed up there in the middle. So I'll put a clip here and here, which will help push down that seam. At least that is the thought process. That may not even work. That may not work. We'll see. We'll figure it out. Like I said, to date, I have not done the bottom plate. And it looks like I may wind up having to cut it out of a sheet of ABS. I do have the capability. I was just being lazy. How did I drill out the heat set for the cutter? Put it in a pair of pliers and drilled it out. And by pliers, I mean a pair of flat jaw Nitehawk-SB. Yeah, the other thought I had was potentially trying to make this a solid plate through using ABS, but I'm seeing that this is not going to be able to go on with clips, being the way that it's been done. So I'm probably going to have to cut this as a single piece, because that's going to droop down and just look like dog doo-doo. So the way this will work is our 4-pin cable, right, is going to come down here and plug into the jack. Get it to line up. Black on black. Here we go. Here's the right way. Damn it. And that just pushed all the way through. Urgh. I just pushed the keystone jack all the way through. Let's flip this back over and try and figure out why my keystone jack decided to pop out. Yeah, 3D printed keystone jack just isn't all that. So we'll have to take a look at that. Maybe I'll have to wind up just super gluing that in to ensure that we get a good connection. I'm jacked through again. At least it feels like we got locked in that time, but all right. Good news is we're locked into place. Bad news is Keystone Jack itself isn't. Makes this more fun. Might wind up having to transport this as a single piece. Not that that will be that hard. Really, I was doing this because on the first one I was messing with, it was a 350, which is just ungodly heavy. Or at least heavier. What is going on? Order all the ABS to print the box turtle, dude. Yeah, like I literally may put some super glue on there just to hold that, try and hold that in place better. Which will make it more fun to take out if I ever need to take it out. But the desire would be to not to have to take it out. And I think while we have it like this, should we close up the bottom? I think we probably should. I don't think we're going to need to get into the bottom anymore. And sure, if I were you, I wouldn't complain too loud about having to buy more ABS for Box Turtle, because Thunder Keys might hear you. I think he was reprinting parts more than I was, because every time he turned around, they were releasing new parts. He was having to try and test them out. In my case, I was just like, okay, I'll just do that on the next build. Beta Rev 2 build. Okay, deck panels on. This is connected. We should be good to flip this up on its feet. Set the panel just on top for now. I still need to do the, dang it, that's what I meant to do as well. I need to put the speed on these. Great if Thunder Keys was here, but I don't think he is. I have a feeling that these are not M3 by, oh, they may be M3 by 10s. Rock on. M3 by 10s. Now, what do I need to do? Take that room. Okay, there is no way that these go on there. Well, maybe. Maybe not. It may go on there without the plates fully in the corner. Oofed. You stop doing that. Okay, yeah, looks like I can't do these panels because if I do the panel with the way it is, then these side feet don't work. And I want to do the side feet because these will let me kind of elevate the box turtle and set off the top lip. And I'm going to have to take these off. Isn't this so fun, guys? So that comes off. This comes off. I can leave that on. I just need to undo bottom rail. Yep. I'm gonna take these. So the feet, you have to kind of slide them on from the side. There's no real way to get them on any other way because of the way the grooves are in them. They kind of have to slide on from a side. One, there's two. Now we gotta make sure that we don't catch a wire as we try and line this back up and get this back in there. And I'll blame Thunder Keys for this one because I think this is his design. I just realized you guys can't see exactly what I'm doing, huh? Apologies. Okay, so now we've got these 2 feet on. They're not secured in any way right now. I do need to add some blind nuts, slide them in, and then we can secure them down. Like I said, though, in doing this, I think it's either going to be these standoff legs or the bottom plate, but I'm not going to be able to get both. Don't think that bottom plate accounts for the standoff legs. And so this is from the side, this is from the bottom, and the bottom plates come up to where this middle joint is. So I would have to cut off some of this to make these work with the bottom plates. So just no bottom plate for now. Look at see ugly wiring. At least until I can design some type of plate that'll go on it. And we'll do our M5 rolling T-nuts. And I'll probably set these up for the front and, all the way to the front and all the way to the rear. just like that. And there will be screws that you can put in here that can latch it down. I don't think I'm going to do those just yet. Flip that over, move this around. Two and a half millimeter driver, and that will take the corner plate off. With the corner plates off. M3 to take our feet off. Well, you'll be able to look up underneath here and see. Sorry, folks. Then we'll take the side beam screws out. That'll let our beam come out. And once again, just going to slide on there like that. Slide on there like that. There we go. And then make sure that when we slide this back in here, we have it in the right orientation so that our feet are facing down. It's not too heavy. It's just something that you don't want it. Well, let me rephrase that. The box turtle isn't heavy, but think it through. The box turtle is only part of the equation. The other part of the equation is the 4 kilo spools, which is going to be what? Almost 10 pounds added on top of the box turtle to the top of your printer. So that's the bigger issue, is adding the additional weight of the spools on top of the box turtle. And now you're talking a significant amount of weight at the top of your printer. So you really don't want all that weight sitting on top of your printer. It will deform or cave your panel over time, especially if you're printing high temp materials. I mean, I literally don't know how much the box turtle by itself weighs. I don't know. But yeah, like I said, you're going to have to account for the close to 10 pounds of weight on it from the material. So the other reason I'm moving this back, or front to back, side to side, is the LDO kit is provisioned with handles, right? So there's the possibility that if we put this front to back, that we will still be able to use the handles. Possibility. I'm not 100% sure, but there is going to be the possibility. Like I said, I'm just going to set it on there for now. We'll be able to we should be able to lock this down with screws. Dang, it's going to get in the way of the handles. It's going to get in the way of the handles. So it's either box turtle or handles. There we go. The box turtle's sitting there. All of its weight is going down to the frame. So there's no weight under the box turtle or from the box turtle on there. The box turtle is now plugged in. Let me apply power back here. That is good, solid connection. Should hear wheels going. Right, I did not somehow shut that off. I did not. Booting up. Oh. It's got power, but it doesn't know how to talk to it yet. So I've got Linux booting up on this side, and I probably should have tried to pick this up and move it around beforehand. Okay. We try and put some things back around the way they were. Okay, we've got our lights on, we've got our panel semi in place, kind of not needed right now with the box turtle up on its legs instead of its feet. We still don't have clipper screen, so we still need to figure out why our clipper screen is not working. Let's go into the interface and see if we can figure out if we can't home X. That worked. Home Y. All right, so that's not working. Looks like that was coming forward instead of back, so the Y direction appears to be wrong. Let's check that. X is moving in the right direction, Y moved in the wrong direction. LDO document time. Or not LDO, Voron docs. Dang it. Voron design. Documentation. Build. Initial startup. X went the correct direction, Y went the wrong direction. Okay. 0, V2. X went in the correct direction, Y went forward. Steppers are swapped. Swap A and B connectors. Seriously? It hates me. It hates me. Okay, move the stool over there. Bring box turtle and set it down on the stool. Upper top. Stick it back over there because it doesn't look like we're going to need it for the time being. Power down. This for the time being. Hey, Pezliz, you had breakfast and lunch. Yep. Yep. And it just told me that my X and Y or A and B motors are reversed and I need to swap them. So we're gonna fix that. We'll undo we'll swap our belts over. Well, not belts, but our things over. I thought I put them in there in the right spot, but maybe I was mistaken. Okay. B then A. Just for curiosity's sake. Not Nitehawk. Back up to the LDO docs. Sure. Positron. Sure. Wrong one. Docs LDO. Get up for FC is fine. We'll come over here to D. This is basically what we're trying to do. Connecting steppers. Sorry, you guys don't see what I'm doing. Yeah, I'm still on Rittenhouse. Probably won't be too much longer, though. I just realized it's almost 6 o'clock. Possibly Otter's Danger Den. So A is there, B is in the middle. That's how I have it wired right now. Is A is on the yeah. I've got them wired that way now. It's telling me pound sand and that I'm going in the wrong direction. So I will swap these two around. Apparently easier said than done. Is there extra here or? Oh yeah. You go there. You come there and yeah, so the issue here is X was going in the right direction, Y was going in the wrong direction. So it says to swap the motors, so that's what I'm going to do. Don't know. Could have just needed to change directions, but I can never really tell. Is it like a change of direction thing or something else? So it says swap the cables. Sometimes it's just easier to swap the cables and not chase a bunch of other stuff. So now the good thing is this is like a one and done type thing. Once you get this figured out, you shouldn't have to mess with it anymore. So fingers crossed. That was all that was needed. And our XY will be going in the appropriate directions. I have little faith, but at this point, it may be going in the wrong direction and we just need to change a direction because it said swap cables. So when it says swap cables, I think it's more mechanical than directional, right? Lunch or lupper. Yep. Yeah, this has just been long, and I'm just trying to get this worked out so that I can get, if I can get movement in the right direction, that's good. And we can start working on box turtle. So X should go that way, right? So does X go in the right direction? It does. Does Y go in the right direction? It does. 2 for 2. Okay. Does Z go in the right direction? Yes, it does. Is it going to trigger? Yes, it does. Good test. Use your hand. It's nothing's hot. It's better to do that than let things ram the bed. Or better yet, hit the bed and go, was it negative Z China? Keep going. I'm going to let it QGL. And I'm most likely, I think what I'm going to do is put side panels back on. The rear panel, I'm still going to need to swap a piece out on. So I'm not fully tightening these down, but by getting the bottoms in place, it's going to allow me to drop the panel in. So I can drop the panel in just like that. Now it stays there. And I can come back in and put a couple of other pieces in play. Okay, so QGL worked. Still got to figure out the screen. Don't know why the screen's not working. I'm also going to try and get my mat out from underneath there because that will throw off my QGL. Seeing as how one side is slightly up and off the table. Once again, this will sit nicely in the trough there. That's good. Screen. What can we do about the screen? Normally, what I do about the screen is go back in, uninstall, and reinstall. Restart the session. Log in as Pi, Raspberry, // Kaya / Kaya shell. No. We're going to remove screen. We're going to remove clipper screen, which is, what is it, 7. We're just going to remove it and then re-add it, see if we can't get it figured out. Got there. I screen, you screen, we all screen for clipper screen. Yeah. Okay. That's done. So we're going to go back. We're going to do an install. So 1, clipper screen, which is 5. Right? Yep. Let's see if for whatever reason, just writing the script a second time will get it to figure itself out. Okay. Install standalone. Yes. Default X server. Yes. We want to use X server. Okay, so one side's done. You're making chicken parm. Pork tenderloin has about 15 minutes or so. Nice. Nice. Okay, so the doors are on. The one side panel's on. I need to do the other side panel, but I've got too much going on over here. kind of like this tripping hazard. So let me see if I can not make it so much dangerous for myself that I fall again and break something else, because that would be bad. You know what? I'll wait. I'll put the other panel on once I can move things around. Safer that way. So the other thing that we still need to do is the box terminal has a physical connection, but it's not, no talkie-talkie, right? We got box turtle up here, looking all nice and good, but there's no talkie-talkie. And I don't know if, oh, well, that sucks. Bear with me, folks. I completely forgot about an appointment that I was supposed to be having in, like, I don't know, now, or no, 30 minutes. Yeah, that's not going to happen. Give me 1 second. I was going to ask if Mrs. Dragon wanted to drive out there and take it, but that ain't going to happen either. So I don't think I let smoke out of any chip. I got blue lights on the AFC light. Bear with me, folks. Okay. Yep. No, that was all me not paying attention. All me not paying attention. I was supposed to be having a massage in like 30 minutes, and there's no way I'm getting there. Even if I cut the stream right now, there's no safe way for me to get there in 30 minutes. So late cancellation, eat the fee. Oh well. What I get. Good thing is I got one for next week too. Oh no, no, I just looked at my phone and was like, uh-oh, that's not good. That's not good. So where are we at here anyhow? We're up, the extruder's up, the heater's up. I'm just trying to figure out, like, why am I not getting a light? Because I had a light. Why is my light not working now? Did I somehow turn my still printer light off? So I had light. Now I don't have light. Don't know why I don't have light. Okay. And double check. We should have removed all the light information out of here. Should all be commented out for the we can uncomment this. And because we do have a filament sensor. I'm not going to worry about the switch because the switch itself will be redesignated in the Nitehawk board. Chamber case lighting is there. The NeoPixel for the tool head, we uncommented all of that information because we're using the stealth burner stuff. Yeah. Save. I'm not going to save and restart. I'm just going to save. Stealth burner LCDs. We did put the NeoPixel 7 in there, so that's good. Oh, crap. Maybe. Hold on. So what do we got here? We've got X and Y end stops have been commented out. The probe has been changed to GPIO 12. Stealth burner headlights here has also been commented out. Huh. So I don't know at this point why my stealth burner light stopped working, unless it's something that's being done by clipper screen, which that doesn't make sense. Sorry about that. Because the lights were working earlier. I don't know why. Everything else on the tool head seems to be working. Okay, it's creating a virtual environment. Do not know. you want to install the network manager? We said yes. Kind of like the pain, because now once this gets added in there, there's stuff in the way and it's not real easy to see the screen and still show the screen to you all. Communication is required to reboot the system. Call to reboot failed, connection timed out because I waited too long. So I don't know what that happens or why that does that, but when it fails to reboot, I think it fails to continue to do something it needs to do. Which then causes other things to fail, or something may not have installed. Which might be why this isn't doing its thing. All right, so I'm going to continue playing with that off stream, folks. I think at this point, and I was about to come over and just say main view, and I'm pretty sure this camera, oh, it's working for 30 seconds here. I think I'm going to go ahead and get ready to raid out. Pretty late. I do want to continue playing with this a little bit tonight. I'll try and get clipper screen working. I know it fights me at times and it's a pain in the ass, but we'll make it work. But it's now 6 o'clock. I've been streaming for 9 hours. Yeah, Mrs. Dragon's probably going to scream at me, but yep, there, yep. The camera has frozen yet again. So apparently I get a couple seconds out of it until it realizes it's working and then it like freaks out. So we're going to go ahead and see who is online that we can raid over to. Yep. And boom. We're going to raid on over to the Free Heathen, everybody. Thank you so much for being here. I'll switch over to the bench side and kind of do like this. Thank you, everybody, for being here on this Veterans Day. I really do appreciate it for the long stream. We made a lot of progress here, so we're doing good. A little bit more frustration to go, but I think we've made it over a lot of the hurdles. I'll figure out the light and the whatever's going on with clipper screen. I know that's just a software thing, so I'll get that squared away. And then we still need to work on getting the box turtle talking. Like I said, I am seeing lights on the box turtle board, so I know it's getting power. We just haven't gone through and done any of the, validated the whatchamacallit, the CAN bus stuff for it yet. So thank you everybody for being here. Have a great one, and I will see you guys next time. And that next time is going to be tomorrow for a regular stream. Bye now.